and say you have subclasses of it, like square, you would have circle, and so on. So now basically you want to ensure that when you create a subclass of the shape class, you want to ensure that that particular class implements the area. That's when you create it as abstract. So the shape method would have, or the shape class would have area method as abstract, which would be implemented by the subclasses, which has to be ensured. It's kind of ensuring, or if the subclasses don't actually implement it, you would get a error. So basically circle would have its own implementation of subclasses don't actually implement it, you would get a error. So basically circle would have its own implementation of area saying pi r square. Square would have its own implementation saying side square. So basically what I'm trying to say is area is a abstract method for shape class. And when you have an abstract method, the class itself is abstract. So you have like shape com.edureka.shape. I'm creating a class. Now I'm creating an abstract method. So when you say abstract, you don't have to provide implementation. It's just generic this thing. You don't have implementation of it. You just have the signature of it. So basically, as I said, when you have an abstract method, the class itself should be abstract. So we'll have to make this abstract as well. So you created a shape class which would have an area and which would give you this thing. So basically, if you want to have subclass, I don't want to show how the subclasses are created at this point, but basically this is what abstract is all about. You don't have the implementation of it, but you're ensuring that subclass is implemented. So here you can see it's just a signature. You don't have implementation unlike this. Implementation is nothing but if you write something within these braces, this is an implementation for this particular method. Whereas in shape class, you just provided the method signature, but we don't have implementation of it. So that's what abstract is all about. Synchronized and volatile is much about used in threads. Synchronized is we are saying that only one thread could get a control at one point. So as we said, threads are nothing but parallel execution. You could have thread, say for example, you could have thread one calling a method. So we have a non-static method test, right? Say this is a method. So what we are trying to say here is if it's synchronized, we can make this as synchronized, private synchronized. So this is what ID is all about. So when you have this integrated development environment, you don't have to type everything. When you type SY, you could see synchronized coming up here and you could select it. So when you put a synchronized here, what we are trying to say is only one thread could access it at a given point. Only one thread at one point. So if multiple threads are trying to access it, one thread has to wait for it. So only one thread would get an entry to this and the other thread should wait for it. So that's what synchronized is all about. And volatile, it's basically for memory visibility, or what we are trying to say is, so basically every processor has got its own cache. So what we are trying to say is when you use a volatile access specifier, don't store it in cache, store it directly into the main memory so that all the threads would get the most recent value being assigned to a variable. And also volatile is not needed when you have using synchronized as such. So it's mutually exclusive. So let's talk about variable. So variables are nothing but it's a holder, right? It holds value, and variables are nothing but it's reference to that particular or it's a address or something that is pointing to a memory location where the values are being stored, and you could access it using this particular variable name, or you could access the memory location where the value is stored using a variable name. What I'm trying to say here is, so this is a variable and you could access, so this 10 is stored somewhere in the memory and you could access this part of memory location where this 10 is stored using this variable, or you can manipulate it as well. You can change the value. So basically there are three types of variables in Java. There's local, instance, class, or static. Local is nothing but local to your method. Whenever you have a method or you kind of create a variable within a method, that is nothing but local scope, which is like it has the access, its visibility only within that particular method. Once control goes out of this method, you can no longer access this particular variable. That is local. So if I define something here, say for example, I define something here. So this is a local variable since it's defined within a method. So once the control, you would have this only within this particular method. Once the control goes out of this method, this is no longer accessible. Basically, this is where garbage collection for Java is useful. Once your control goes out of this particular method, garbage collector would kick in and would clean off this variable or clean off this particular memory location, or would make it available for use. So that's the local scope. The next one is instance. Instance is nothing but something that is defined at the instance level. So this is instance variable. So since it's at the class level, right? This is, you could see it at the method level. This is at the class level. So this is nothing but an instance variable. Now there is static variable as well. So this is how you define a static variable. So instance variable is nothing but it's per instance. So you could go and change this instance variable to something else. Suppose I assign a value 40 here. Now I could have one more object created. Suppose I call this object 1 and I have hello world object. So I create one more object here. So what we are trying to do is we are trying to change the instance variable through objects. So basically this is what it is. When you have an instance variable, normal instance variable, which is non-static, you could access it through objects, right? So through object one, you assign for object one, you assign instance variable value to 40. For object two, then you change the instance variable value to 50. I won't say changed it, but you assigned it. This is how you deal with instance variable. It's at the instance level. It's at the object level. Whereas for static, it's at the class level. It's one per class. It's not one per instance. It's one per class. So basically what you can do is you could do something of this sort, wherein it's at the class level. It's not at the object level. You are assigning value 100 to a static variable. So as you could see here, it's not a particular instance that you're operating on, it's the class directly. Just to give you a gist, we have local variable, which is within a particular method, and scope remains within a method. Once the program control moves out of this particular method, Java would or JVM would come in and kick in garbage collector to clean this off. It's only accessible within this method. You have an instance variable, which is at the class level, but it's non-static, and which means that it has copy per object. When you have multiple objects, you could change the values the way you want per object. Static is nothing but one per class, and as you could see here, we changed the value of the static variable to 100 through class. So that's about variables. We have an instance. So instance variables are declared in a class when the space is allocated. I'll just read through this one. So when a space is allocated for an object in the heap, a slot for each instance variable is values created. We had a teacher instance variable, and whenever you create, but basically an instance of a class is created in a part of a memory which is called heap. So whenever hello world object is created, a slot for this instance variable would be created as well. Instance variables are created when an object is created with the use of keyword new, and destroyed when the object is destroyed. So unlike local variables, which is within the method scope, instance variable is within the class scope. So basically, whenever you create an instance of a particular class, your memory would be allocated for that particular instance variable. And whenever it's done, whenever it's destroyed by the garbage collector, it would go off. Access modifiers can be given to instance variables. You could have like private, public, protected, default. All the access modifiers be assigned to an instance variable. So basically you could have it as private. Private is just within this class. You cannot access it outside this class. You could have public as well, which is like could be accessed anywhere within this application. You could have protected, which is like within the package or the subclass, and you could have the default one, which is nothing but package access, which would be accessible just within this package, that is com.edureka. So instance variable have default values. For numbers, the default value is 0. For Boolean, it is false. And for object references, it is null. So values can be assigned during the declaration or within the constructor. You could assign values directly while declaring it, something like this. Instead of 0 is the default one for integer as they have mentioned. But yeah, you could assign, if you put it as 10 here, it would be taken as a default value instead of 0. Constructor is nothing but a method which constructs an object of a class. Values can be assigned during the declaration or within the constructor. Instance variables can be accessed directly by calling the variable name inside the class. However, with static methods, when instance variables are given accessibility, they should be using fully qualified name. So what we are trying to say here is this is a static method from which we are trying to access instance variable. In this particular static method, you need to have object reference. This is the object that we created. So object reference dot instance variable. You need to have, as we have mentioned here. So here, as we can see, object reference dot variable name. You need to have fully qualified name. When you try to access it within the static method, you need to have fully qualified name. Whereas here, within a method which is non-static, this is non-static. Here I can access instance variable without object reference. So here, as we can see, it could be accessed without. But if I do it here, it would throw me an error. It's not accessible here at all. Non-static field instance variable cannot be referenced from static context. Instance variables are not accessible directly here. It has to have fully qualified this thing, which is object reference dot instance variable. Whereas when it's called within non-static method, you could use it direct. So static, as we spoke about, it's one per class. So it's declared using static keyword. So static variables are stored in static memory. It is rare to use static variables other than declared final and used as either public or private constants. As we said, it's mostly used for constants, and static variables are created when program starts and destroyed when the program stops. So one thing to remember is it's one per class. It's not one per object. Instance is one per object. You have a copy of that particular instance variable, one per object case of instance, whereas case of static, it is one per class. So the scope remains, or the life cycle remains, right when the class is loaded till the program is stopped, till the class is unloaded. Static variables are declared public since they must be available for users of the class. It's not mandatory though, but usually if it's a constant, it is declared as public. Static variables can be accessed by calling with the class name. So we saw here class name dot static variable. So how do we decide what amount of memory is to be allocated? So these are the data types that we have. So each variable in Java has a specific type which determines the size of memory, the range of values that can be stored, and the set of operations that can be applied to the variable. Data types can be categorized into two major types, primitive and non-primitive. So basically primitive is not object. Primitive is supported by language itself, which is kind of, it has got 8 primitive, or it's predefined by the language and named as keywords, and it has 8 primitive data types, that is byte, short, integer, then you have long, float, double, character, and boolean. This is pretty much similar to other programming languages that you have. Byte, it consumes one byte. These are 8 primitive data types that are predefined. Non-primitive is nothing but string. String is an object itself, so that's something that is non-primitive. Or if you define your own class, say student for that matter here, right? We have defined student class, that's non-primitive. So the student class is non-primitive. We have strings for storing string, which is again kind of non-primitive. We have arrays, or basically it's all called as reference variables, since we're referencing a particular memory location through variable name. This is where we have table showing byte consumes 1 byte and its range is from -1 to 8 to 1 to 7. Short is like 2 bytes, and you could imagine that it would be from -3 to 768 to 3 to 767. So it's pretty much similar to other programming languages that you have, like in C as well, we have similar to this thing. One thing is charac takes 2 byte, in C it takes 1 byte, I believe. Though it doesn't use all the 2 bytes every time. It depends on encoding type. So Boolean is 1, which is true or false since it has to store 1 or 0. So yeah, it's pretty much similar. So just to talk on the bytes required, byte is 1 byte, short is 2 bytes, integer is 4 bytes, long is 8 bytes, float is nothing but it has decimal values stored, signed decimal values. So it again consumes 4 bytes. Double is signed again float values or signed decimal values, which consumes 8 bytes. Character is 2 bytes, and Boolean is 1 bit. So basically, to decide whether to use float or double depends on the nature of the application. So if you want to have more precision or if you want to have more range, you could go with double. So non-primitive or reference data type is a variable that holds a particular object or holds bit that represents a way to access an object. It's a pointer to a memory location basically. So as we spoke, Java doesn't expose the pointer directly. It doesn't give you directly pointer to the memory location, but it gives you the reference variable. So you cannot manipulate memory location directly. You cannot add some values to the memory location through pointers or something, but through reference variable, you can access it and assign some value. So yeah, it does not hold the object itself, but it holds a reference address to the object. Reference type does not have size or bit range. So here we can see string str is equal to edureka. So the one shown in red is actually the memory where edureka is stored. You have a reference and str is the reference to it. So here we can see variables and data types. So we have a main method again, and we have byte. We declare a byte here. Byte b is equal to 10. Short s is equal to 20. So I think it's pretty straightforward. You kind of have this data types created. You just have to assign values to it. These are all primitives, as you could see. Till here, it's primitive. So you could see that values are being assigned and it's been printed out here. So I think it's pretty straightforward. You can assign a value to a variable and just print it. So again, we use system.out.println for printing it. You could try it out on your own. You could try it out this data type program. You could just assign something and just try to print it out. We are talking about data type conversions. So we have implicit and explicit conversions. In some case, programmers don't have to actually write explicit conversions from one data type to other, but in many cases, programmers need to. So the arrow in the diagram shows the possible implicit type casting that are permissible with primitive data types. It's just with primitive data types, right? As the diagram shows, int can be converted implicitly to long, float, double. Since int takes less space, it could be applied to any of the numbers. For vice versa, they have to be converted explicitly. Whereas if you want to convert long to integer, you have to mention it explicitly. So basically, we are talking about when you're trying to store integer into long, integer takes less space and long takes more space. So it can be easily accommodated. Since long takes more space, if it is more than the range of the integer, it wouldn't know how to assign it to integer. So that's why it has to be explicitly converted. Implicit conversions, we can on the J shell, you could type this. So here what we are trying is we have a character C is equal to A, and you could see C is assigned A. Now integer K is equal to C, which could be done. You could assign character to an integer. So basically it's a ASCII code for it. So 97 is the ASCII code for C, which would be assigned to K. So now when you assign C to float, which works as well, so you get 97.0. You could assign character to long as well, which is 8 bytes integer. You could assign double as well, which is 8 byte float, and you could see. But it cannot be done the other way around as we spoke. So you cannot have integer or you cannot have double assigned to character. So it would give you incompatible or possible lossy conversion from double to character. It has to be explicitly done if you want to do that. Need of type conversions. So here we have integer a equal to 100, initiated a variable with type integer. Then you have a string b, which is assigned value hello. So basically here you can see string being used, which is a reference variable. And you have string s is equal to a plus b. S equal to a plus b, then it adds up like 100 plus. Since hello is a string, it would concatenate it. So you could see 100 and hello being concatenated, and you could see 100 hello. The data type of both the variables are different, but to perform any operation, we need both the variables to be of same type. Here, integer value is converted into string and gets concatenated with other string. So basically, had b been an integer, you would have got addition of it. Say, for example, integer b is equal to 200, and if you 100 plus 200, you would get 300. But since it's a string in this case, 100 is converted into string and it's concatenated with hello. Explicit type conversions. We saw the previous case wherein double was being assigned to character, which prompted us with lossy conversion. So this is similar to that. So basically here what we are trying to do is we are trying to assign double to integer. So you have double, d is equal to 45d, which is 45, right? Again, double is 8-byte decimal signed decimal number. So you assign 45 to it. And now we are trying to assign this double value to integer. So it's possible lossy conversion. But you have a provision to typecast it. So basically what we are trying to do here is you're trying to assign again double to integer, which is possible if you typecast it. So when I say typecasting, it's nothing but opening parenthesis, then the destination data type, then your data, actual variable. So basically to the right side, you could see that through explicit typecasting, we can assign double to integer. So casting may lose information. For example, floating point values are truncated when they are cast to integers. Example, the value of d, that is 45.5, when converted to integer gives 45. So we could see here in the bottom, like the double, we assign the value of 45.5 to double, but when we converted into integer, we got 45.5 was truncated. Since integer, since the destination data type that's integer doesn't store decimal values. Now this is like type conversion methods, which is there in your wrapper classes. What we are trying to do here is we are trying to convert 23, which is string, into integer. So you have a string s is equal to 23. You assign the value 23. So mind you, this is string right now. We have integer dot parse int, and we pass the string, which would be converted into integer. So this integer class that you see here, right here, is nothing but a wrapper class. You have string into integer, which is nothing but integer dot value of string, which converts it into integer data type itself. So as you could see, the destination is integer. Now integer to string, you have integer. We have a toString method which converts integer into string. So basically you have integer I, which has been assigned 23. Now you have integer dot toString I, which would convert this integer into string. We have one more method, which is string dot value of, which would also convert integer into string. Let's talk about operators. Operators are nothing but it operate on these data types. So you have unary, which is kind of pretty much similar to what you have C, C++. You have postfix and you have prefix. Postfix is I++ or expression++, and the operator is after the variable, which means that it would be assigned value and then it would be added. Prefix is before the operator, which would be added first and then assigned, or the operation would be done first and then assigned. That's prefix. Arithmetic is pretty much similar. like multiplicative, you have like multiplication, division, and mod. You have additive, which is plus and minus. You have shifting operation, which is bits shifting to the left and bits shifting to the right. You have relational operators, less than, greater than, less than, equal to, greater than, equal to, instance of quality of two data types or two variables, which check whether they're equal and not equal. We have a bitwise and bitwise XOR, bitwise inclusive OR, which is happening at the bit level. We have logical and logical OR. So basically this is for conditions, right? If you want to have like two conditions, like if int I is greater than 0 and int j is greater than 0, sort of you add or you have logical ANDing between two conditions, logical conditions. Or logical or pretty much similar to other programming languages, like it's or between two conditions. We say that either this or that. We have a ternary operator which says that if the condition matches, we would have a condition followed by question mark followed by colon, and we would have some value followed by colon followed by some other value. So what we are trying to say here is if the condition is true, assign value 1. If the condition is false, then assign value 2. So instead of having it written in if else, you try to put it within ternary operator. So basically this is when you have simple assignment operator. If you have a logic, if you have some particular logic being written, it would be a better practice to have if else so that it's readable, right? Because ternary operator, it would be very difficult to actually read through. We have assignment operator, which is equal to, which is plus equal to, is nothing but adds the value on the right hand side to the left hand side and assigns it to the left hand side variable. Minus equal to does the same thing. It kind of subtracts value to the left hand side from the value to the right hand side and assigns it to the left hand side. So I believe this is pretty much similar to other programming languages. There's nothing different in this. We might have used it somewhere or the else. Should be pretty much simpler for you guys. So let's see unary operator example wherein x is equal to 10. So you could see x being assigned value 10. You have x plus plus. As we said, it assigns first and then increments it. So you could see value 10 here again. So now if you, after this, if you print the value of x, you should see the incremented value, that's 11. So that's post increment. So let's see pre-decrement. So you have a been assigned the value of 10. All right, now you do minus minus a, which is pre-decrement. You would see the value 9 directly. And now if you print the value of a, it would be 9 again. So basically this is like decrement and then assign. This is like assign and then operate. This is like operate and then assign. Let's see the negation operation. Like a has a value of true. Now we negate it and assign it to the variable d, and you could see that it's changed to false. Now let's see the arithmetic operator. You have b, which has value of 20. We have d, which has value of 30. So when you add it, it gives you value of 50. When you multiply it, it gives you the value of 600. 30 into 20, which is 600. When you divide it, 30 by 20, you get value 1. And when you have mod, which is like remainder, which gives you value 30 by 20, which is equal to 10. Shift operators, so it shifts to the left. So shift left, shift right. So basically you have integer value of 20, and if you convert this into binary, if you convert the 20 to binary, which comes out 5 digits, right? So when you convert this binary and when you shift it to the left, you would get the value of 80. So you have value 20, which is nothing but, if you convert this 20 into binary, which would give you 10100, right? Now what we are doing here is kind of shifting it to the left by 2. This is what you do, and this is what it shows up as value of 80. So this is nothing but 64 plus 16. So that's what this left shift does. Basically it's shifting to the left by 2. Again, you could have shifting to the right by 3, which would give the value of 2. Just shifting to the right by 3 would be something like this, right? So yeah, basically it shifts it, and you could see that, yeah, basically it would end up to 2. So now we have like relational operators, which is pretty much simple, like a less than b, it gives false, a greater than b, a equals b. Since you have a is equal to b, in this case we have a equal to b, that's why we have a less than b as false and a greater than b as false, but whereas a equal to b is equal to true. We have arithmetic operators pretty much similar. Basically you have add, you have multiplication, you have division, you have mod. So here we have a is equal to 20. So what we are trying to do is assignment. So a is equal to 20. Now b is equal to 40. A plus equal to b, which is nothing but, as I said, your left hand side would be added up to the right hand side and would be assigned to the left hand side, which is nothing but 20 plus 40 would be assigned to a. So when you print a, it would print 60. Ternary operator, which is nothing but if a is less than b, here we can see that if a is less than b, then the value of 100 should be assigned to tr, or the value 200. In this case, the value 200 is been assigned. A is greater than b. Logical operators is nothing but ANDing and ORing of conditions. Yeah, here we are saying that a is less than b and d is less than b, then return false, and it's like kind of ANDing logical conditions. Now let's talk about the control statement in Java. Now again, this one is pretty much similar to other programming languages, nothing different in Java. So you have control statements, you have iterative statements, you have jump statements. So one is selection or decision making statements, which is like if else ladder. You have if this particular condition satisfies, do some things, do some execute group of statements, and if it doesn't, then execute other group of statements. That is about if else. Switch is nothing but based on the value of a variable, like you execute different step of statements. Like say for example, you have you write a switch on integer variable x. Now when x is 1, you do something, or if x is 0, you do something. Or you can have a default statement as well. When x is neither 0 or 1, do something else. That's about switch. Iteration is you repeat the same set of statements again and again till a particular condition is met. That's iteration. So you have for loop, which is like after every iteration, the value of variable or the iterating variable would be changed and would be checked against a condition. And if it meets, it would come out. Or if it meet, it would execute it again. And if it doesn't meet, then it would come out. So yeah, this is pretty much similar to other programming languages. So for int I is equal to 0, I is less than 10, I plus plus, and you write something within it. So this loop would go on for 10 times from 0 to 9. It would break, it would come out when I is greater than 9, which is 10. When it goes to 10, it would come out. While is again pretty much similar to that. You have do while construct, which is guaranteed to be executed once, because the condition is checked after the execution is done once. So basically, no matter what the condition is, it has to be executed once for sure. That's when, if that's the behavior you want to put into your program, you would use do while, execute once for sure. Jump statements, you have like break, which come out of for loop or any iterative statements. You have continue, which would again continue, and return is again coming out of a method, or yeah, mostly from the methods you return something. So the control leaves the method. Now, just to give you what if else is, if the condition is true, then execute the conditional code. If the condition is false, come out of the execution or come out of the conditional code. Skip the conditional code. That's what if else is. So here you have int I is equal to 10, int b equal to 20 if I is less than b. So it's pretty much similar to the ternary operator that we had. So you could see here tr is equal to a plus b. So basically the value, if A is less than B, which is in this case, A is equal to 10 and B is equal to 20. In that case, you would have TER as 30 since it is true. So basically it checks the condition, and if the condition is true, it executes the code with it. Now let's talk about if else. If else construct is nothing but you have a else set of statements to be executed when the condition doesn't succeed. So in this case, if A is less than B, TR is equal to A plus B, else TR is equal to B minus A. So in this case, it was less than A is less than B. So you got the value of 30. Whereas if A is greater than B, we have again changed it. So if A is greater than B, then TR is equal to A plus B, else TR is equal to B minus A. So in this case, A is less than B. So which means TR should be B minus A, which goes into the else condition statement. And here you have 20, B as 20 and A as 10, which is 20 minus 10. So you should have TR as 10. So here it's pretty much same. It does the same thing nested if else. Now we are talking about the switch statement. So you have switch expression and you would have case written against it, whatever case you want to execute. So basically you would have for value 1. So yeah, what we are trying to say here is we have a switch expression and we have a value for value 1 as its value, then execute this piece of code and then break out. And if it has value 2, then execute this piece of code and then break. If it doesn't match with value 1 and value 2, then execute the default cases. So one thing to note here is it's mutually exclusive. Only one of it would be executed out of the cases. Make sure you break out of all the conditions. So to the right hand side, you could see integer ch has a value of 40. Now we have a switch for 40. Now case, when the value of ch is 20, it would print case 20 executed. When its value is 30, then we would have case 30 executed. When its value is 40, then we would have case 40 executed and then break out. And if it's neither 20, 30 or 40, we would have a default case executed which says that 20, 30, 40 not executed. So in this case, since it has a value of 40, you would see that case 40 executed as output. Iteration is nothing but it is basically iterating code. If a condition is met, the code would be executed. Until the condition is true, the code would be executed, and once it is false, it would come out of the loop. So basically it's a looping statement. So after every loop, the condition would be checked, and if the condition is true, it would loop again, and if not, then it would come out. There are three types of for loop in Java. Simple for loop, similar to C, like for int I is equal to 0, I is less than 10, I plus plus would be a simple for loop. For each or an enhanced for loop and labeled for loop. For each is basically iterating on array list. Suppose you have some collection, or suppose you have array, right? You don't have to manipulate the indexes, since the typical scenario with array list is iterating through all the elements within the list. So we have an enhanced for loop wherein we don't have to actually deal with indexes. Java has come up with a enhanced for loop wherein for each iteration it would assign the value of each element within the array to a variable which could be used within the loop. So we don't have to deal with indexes, like we don't have to loop through till the size is met, till the loop through till the size of an array is met. Basically it's all done by Java itself. We have an example which would clarify it. So simple for loop is, as I mentioned, you have for int I equal to 10, I is greater than 1, I minus minus. So it would print from 10 to 2. That's a simple for loop. Now what's the syntax for it is for, then open up round brackets, then you have initialization, then you have a condition, and you have increment or decrement, whatever you want to do. Or you could even add up like I plus equal to 2, even that is good enough. It's like for each even number. Not even, I would say, it's like incrementing by 2. Now, this is what I was talking about. So this is for each loop or enhanced for loop, wherein a typical scenario with array is you kind of iterate through each element within the array and then do something within the loop, right? So this is what Java has made it easier for us. So basically, you don't have to deal with indexes here. If you wouldn't have had for each loop, what you would do is you would, till the size of the array is met, you would iterate through and read from each indexes, right? But in this case, as you could see, there's an array, and for each loop, the value within the array would be assigned to this variable, and you could use this variable within. Makes it pretty much simpler for us. And as I said, this is a typical thing that we do with arrays. Now, labeled for loop, it's not recommended to use this often, but still we have these constructs here. So basically, it's like go to. We can have a label of each for loop. It is useful we have nested for loop so that we can break or continue a specific for loop. Normally, break and continue keywords continues the innermost loop, innermost for the loop only. To give rationale behind why I mentioned that this shouldn't be used often is because it becomes very difficult to debug, right? If you dry run it, if you use these labels, it becomes very difficult to actually understand what's happening within. So we should avoid it, and all this could be done by writing a proper construct or using simple for loop as well. So we should avoid it somehow. So basically, as per my experience, this is not a good practice to use it. So type of while loop, we have simple while loop, we have do while loop. All right, so simple while loop is first the condition is checked. If it meets, then the looping statements are executed. Whereas do while loop is kind of the statement is executed once for sure, and then the condition is checked. If it is met, then it is looped again. If not, then comes out. So this is a simple while loop. So you have condition. As you could see here, while a is greater than 1, you print the value of a and you decrement it within. Here it's a do while loop. So no matter what, you would have this 2 printed and it would be incremented. So it's 2 to 9. So no matter what, some value would be printed for sure when you use do while. Now we have jump statements, which is break is like coming out of a loop. So as we mentioned, it's the innermost loop that it comes out of. So that's what break does. If a particular thing is met, or you could write a condition for a particular loop to be broken rather than continuing it. So basically you could have like this would be more or less like you could have an infinite loop, say for example, running through. And if a particular condition is met, you could break out of it. A typical scenario where it could be used. So here you could see that you have a loop from 10 which iterates from where I is equal to 10 and where I is greater than 5, I minus minus, which we are decrementing each loop. Whereas you are saying that if I is equal to 7, we should break out. So here you can see though I is greater than 5, you can see the loop has broken out after 8. Since the value has reached 7, it's not printing the other indexes because it broke out of the loop. So basically, this is like if a particular condition is met and you don't want the loop to go ahead, you can break out of the loop. Continue is similar. When you write continue, it goes to the start of the loop again. It starts the loop again and it skips the messages or it skips the code that you have after continue. So in this case, you could see that we have I equal to, in case when I is equal to 5, we are continuing the loop, which means the print statement for I when I is equal to 5 wouldn't get executed since you're continuing it. So basically, as you could see, the values being printed here, you can see 0, 1, 2, 3, 4, and there's no 5 here. Then we have 6, 7, 8, 9. So basically what we are saying here is when I is equal to 5, don't execute the statement within the loop. Just continue, just skip it. Okay, so what are methods in Java? So method is if you would have written function or if you would have used any programming languages, if you want to perform some operation, if you want to do something, or if you want to do something on some particular data, you would write a method. So basically in Java, methods are defines the behavior of a class. So remember I told you a class is all about state and behavior. So methods are nothing but it defines the behavior of a class. So what are methods? A method has a group of statements. Of course, as I said, since it defines the behavior of a class, you need to have some operations done, right? So you define the operations through group of statements. It is much more used to have reusability of a block of code that minimize redundancy. So imagine if you didn't have methods, then you would have written the same piece of code again and again. Say, for example, you have a method which adds to number, right? And if you write the piece of code to add to numbers directly into the main method, if you want to write it again, or if you want to again add two numbers, you will have to write the same piece of code again in the main method. Whereas if you have a method, what you would do is you would refactor and take this add method or a functionality which adds to numbers into a method, and this method could be invoked from anywhere within the application, which is nothing but reusability, right? Rather than writing the same piece of code, now what you're doing is you are defining this add method into some other method which could be called anywhere within the code. So that's about redundancy. That minimizes redundancy and increases the reusability of a code. A class can have multiple methods, as you could imagine. You could have multiple behaviors introduced into a class, which means that you would potentially have multiple methods within a class. A method returns a null or a value using the return statement. So basically, the intent of the method is to perform some operation, right? So what the method would take is it would take parameters and do some operations on these parameters, and it may or may not return something back to the calling program. So if you don't want to return anything, you have to return null. Or if you want to return some value, you could have, say, for example, you want to return string, you would return a string of a method. You could have void as well, which means that the method is not returning anything back to the calling program. It is doing something within itself, and just the control would be back to the calling program, but it won't return anything out of the method. That's about method. So let's talk about, so what's the syntax of method? So the first one that you see, so this is a method which is public int edureka integer a integer b, and it is just concatenating the two strings or two numbers that we have sent across. So basically, let's anatomize it. So what is public? So public is nothing but again a access modifier. So public means this particular method could be accessed from anywhere within the application. So that's what public means. Similarly, you could have private, you could have default scope, or you could have protected scope. So public is accessible anywhere within the program, private is within the class, default is within the package, and the protected is within the subclass and the package. Okay. What is this int? It is nothing but the return type. So this particular method is going to take two arguments and do something and return integer, right? Name of the method is, you can see edureka, that's the name of the method. Okay, so what you see within the parenthesis after the method name is nothing but the arguments that this method takes. So what this particular method is doing is it is taking two arguments which it is acting upon, right? So it takes integer a and integer b. That's the parameter list. So whenever you want to invoke this particular method, you have to pass arguments in this order. Now, what you see within this curly braces is nothing but the behavior, or this is how you introduce a behavior to the class, or this is how you add functionality to a method. So what you are doing here is kind of adding this to numbers. So what is a return statement? What does it do? So return statement is nothing but you do something, you take the arguments whenever control comes into a particular method, it does something and you return it back to the calling program. So the return statement is a control flow statement that terminates the execution of method and return control to its caller. So when return type of any method is void, then the method does not return anything. If it is void, you won't return anything out. But if it is returning string or something, you would return string, or null if you plan not to return anything. It could be null as well. So here we can see a method by the name work, which is returning void. So you can see that it is not taking any arguments as such or parameters, but it is just printing out saying that Edureka welcomes you. In the second case, you can see it is returning integer. So it's taking int a and b, okay, and then it is printing out and it's returning integer as well. So let's write a program, sample program to add two numbers, and we would be writing all this logic within a method. So let's start off by defining a class. All right, so we define a class, say com.edureka. And a typical name for all arithmetic operation, class with all arithmetic operation would be calculator, right? So I would write it as calculator, for example. All right, so here you can see the naming convention again. There's a package, which is com.edureka, and you have a class as calculator, and it follows camel casing. So it starts with uppercase, followed by lowercase. So you can see the class is being created here. Okay. Now what we are trying to do is you are going to have a method which takes two number. Okay. So say I define, let's keep it public. All right. So this is an access modifier. We want to keep it public. So we want to access this particular method from anywhere within the application. So I'm keeping this public. So typically addition would return results, right? You would add two numbers and return results of two numbers. So that's your return type, which is integer. So you could either write the return type as primitive, or you could write it as a wrapper class. So basically wrapper class is nothing but integer has its own, everything in Java could has to be realized in terms of classes. So integer has its own class. Int is a primitive data type, and integer that you see here is a class corresponding int. So let's put the return type as integer, and add is the method name. Okay. Now this takes two arguments, integer arguments, which is arg1, and let's put the second one as arg2. All right. So we start and end it by curly brace. Okay. Now we have to write logic within here. So what you see here, it's throwing an error saying that you are not returning integer out. There's a missing return statement, because in the signature, this is known as method signature. This particular thing that you have defined here is method signature. So in the method signature, you have mentioned that this particular add method is intended to return integer out of the body, but still you haven't returned integer. So basically, to get rid of this, I could put return null, which means it's doing nothing. Now you can see that we got rid of the error, right? So let's do one thing just to make it more verbose. I'll write integer result is equal to arg1 plus arg2. So this is a method body that you are defining here. So you are adding a behavior, right? You are giving behavior to the calculator class. So by defining add method, this certain behavior that you are introducing. Now you could have a multiply method as well, which would take two numbers and would multiply it, which is again giving some sort of behavior to calculator. So that's the reason we say that methods add behavior to the class. Okay. So here it is taking two arguments, arg1, arg2, adding it, and we will return the result from here. All right, so this is a method that you have defined. But so far, we are not invoking this method, right? We are not calling this method. We want to call and check whether it's running as expected. So that's where we would have main method. All right, when you type main, it should give you suggestion saying that, are you trying to write main method? So once you click on it, it would, this is done by IDE, by the IntelliJ. Similarly, in Eclipse, you would get an option. It would give you a suggestion saying that, do you want to introduce main method? All right. So we have a main method here. So again, it's public static void main, and it's taking arguments here. All right. So remember I said static and non-static method. You can see here add is non-static method. When it's a non-static method, you have to create instance of this class to invoke it. So basically, first thing that I do is I create instance of calculator. So how do you create instance of calculator? It's with new keyword. All right, you create new and it would create instance of calculator. Now I give a call to add method, and suppose I want to add like 10 and 30. Okay, so these are the arguments and it has to be in order. In this case, since both are integer, it doesn't matter. But had it been some other data type, you have to ensure that, say for example, I write string here. What this would return is typically a result, right? Addition of two numbers. Now let's print it out. System.out.println. This is for printing result of addition is. Let's print out the result that we get here. All right, and let's end it by semicolon. So basically you have a package defined here. Within the package you have calculator, and actually it's my bad. I should have defined it right here. So it gives the right package name here. So earlier I had defined calculator within com.edureka. Again, I defined a package com.edureka, which is not required. So yeah, you can see here package as com.edureka, which is nothing but the namespace. We have public class calculator. So public is nothing but the access specifier for this class. Class is the keyword used for defining class, and calculator is the name of your class. Also, one thing to note is the name of the Java file should be same as the name of the class. So that is something that IDE or IntelliJ would do it for you. You just have to create class and it would create a class. So basically, if you go to the source folder, you would have something like calculator.java, right? Then you have public method, which is again, here's the method that we have defined. Public is the access modifier for this method. Integer is the return type. Add is the name of the method. It's taking two arguments, arg1, arg2. Within the body, you are adding two numbers and you are returning result, which is integer, which aligns to the signature that you have put here. All right, in the main method, just to check whether this add method is functioning properly, what you do is you create the instance of calculator, you add two numbers, you pass two numbers to it, 10 and 30, and we are going to print the result and see if it returns as expected. So here basically it should print the result as 40 since adding 10 and 30. So remember, while it builds it, it would compile into a class file. Okay, the .java file would be compiled if it's properly written. If it's syntactically correct, it would create .class file. All right, let's wait for it to run. Okay, so it's prompting me errors that we have in other methods. So let me do one thing. Let me delete the other classes that we defined yesterday. So I go to the source folder, com.edureka. So I'm just deleting these classes that we defined yesterday so that we don't spend time in actually correcting it. All right, so put it into a backup folder. All right, so okay, so we have only this calculator class now. I run this. So yeah, you can see here it has printed result of addition is 40. So basically what it has done is adding these two numbers, 10 and 30. All right, so that's what we have here. So we're adding two numbers. So let's talk about the sequence of how all this is being carried out by Java, right? When you run a particular program, how things work out. When you run a class, the first thing that's been called is the main method, okay? JVM is nothing but Java Virtual Machine, which runs the program for you, which is part of JRE, Java Runtime Environment. When you run a particular class, it would search for a main method. And if it doesn't have a main method, then it would give you an error saying that a class can't be run. So it's pretty much similar to an executable file, right? So if you're trying to run a class, it has to have a main method. or you won't be able to run the class directly. So that's where the execution starts from. That's the entry point for your program. Okay. So once it encounters main and everything is good, your JVM would start executing the statements that are there within your main method. Okay. So in the addition case that we saw within the main method, we created the instance of calculator and we invoked add method, right? So when we ran that particular class, you could see that the addition was done. So basically what's happening behind the scenes is, JVM would execute the sequence of statements that you have within main. So again, coming back to the example, add example. So within the main, you invoke the add method, right? When you invoke add method, the control would go to the add numbers method and it would again execute whatever functionality you have put within that particular method. This case, it was addition of two numbers, so it would execute it. Once the execution is done, it would return whatever is being written out. So in this case, ours was addition of two numbers. So it would return addition of two numbers back to the calling program. So your calling method was the main method wherein you called this add numbers from. Okay. So it would come back to the main method and that's how it prints it out. So following the invocation of add numbers, you could see that we have printed out the result that comes out of this add numbers, and that's how it gets printed onto your console. So that's the sequence of execution that happens behind the scenes. Now, what are the ways in which you could call a method? There's call by value. Call by value is nothing but instead of passing the memory location, it passes the value of a particular variable. Okay. So this is similar to call by value and call by reference that we have in C. Okay. Instead of passing the memory reference or instead of passing the reference, it's just a value that's been passed. So if you change something within the method, or if you change the value that's been passed within the method, only the local copy would change, whereas the main copy would remain as is. But basically, call by value is just passing the value, but not the actual reference. All right, so to understand call by value, so this would give you some idea. So say for example, I have integer arg1, which is equal to 10, integer arg2, which is equal to 30. Okay, now I pass arg1 comma arg2. So what's happening here is it's passed by value. So suppose you change, so what I'm trying to say is here, if you change arg1 to something else, say 100. Okay, so what we are trying to do here is we are trying to pass this to arguments arg1, arg2 to add method. And within the add method, we are changing this arg1 to 100. Basically, we would check whether this 100 is being reflected in arg1 here. Okay, arg1 here would change to 100 as well. Let's see what happens here. Okay, so I print it, okay, before passing it by value. So I print arg1 here, okay, and after I give a call, I would again print it. Printing arg1 after passing it by value to a method, add method. All right, so let's run this. So basically, since it's passed by value, arg1 would remain as 10. Okay, so that's what pass by value is all about. So here you can see arg1 before passing was 10 and arg1 after passing was again 10. All right. So the change that you made here doesn't reflect here. So that's passed by value. All right. So there's one more concept of method overloading. So within Java, you could have same methods with different number of parameters. Same method, when I say same method, it has got a same method name, which would take variable number of parameters. Okay. The overloading happens at the compile time itself. So during compile time, JVM understands to which method you are actually giving a call based on the actual parameters you pass on. So just to give you a fair idea about this, I define one more method. say add, which takes say integer arg1. Let's keep this add as. So I define three parameters here. So instead of two, I define three parameters here. This is nothing but method overloading. All right. So here I define arg1 plus arg2 plus arg3. All right. So we sum it up here and we return it back to the calling program. So one thing to note here is it's not giving you compile time error, right? So you can see that it has accepted this add method as well. So you can see here the signature is pretty much same. Only thing is we have one more extra parameter, which is arg3. So it is treating these two methods as a different method. That's what method overloading is all about. Suppose I define one more arg3, I say 40. All right. So we have three parameters here. I am giving a call to add arg1, arg2. If I put arg1, arg2, the first add method would be called. If I have one more arg3, now the second add parameter or the second add method would be called. So let's define result from new add method, right? So here we say, okay. So as I said, we have overloaded the add method. Overloading is nothing but same method name, but different arguments or different number of arguments. Or it could be different types as well. You could have only two arguments, but one is integer and one is something else. Say for example, string, that also works. So basically different data types, same number of arguments, but different data types or different number of arguments. All right, so here we are adding three numbers and let's run this. So it's going to add 10, 30 and 40, which is nothing but 80. So this is done at the compile time. As I said, this linking is done by JVM at the compile time. So here you can see result from new add method is 80. During runtime, you can see that it invoked this particular method and not this one. All right. Now let's start off with arrays, right? What is the concept of arrays? So again, this is similar to other programming languages. Arrays are nothing but grouping data or grouping values of same data type. Okay. So arrays are used to solve the problem of storing multiple elements of the same data type. Okay. An array is group of like typed variables that are referred to by a common name. So you define a name for the array and in the future you can use this name to access it. Okay. Specific element in an array is accessed by its index. As you could imagine, since we are grouping, you would have multiple elements, right? You could add something to it, or you could delete something, or you could add it to the end, insert it in the between of the array, or just search something, or just search by index, right? You would give some specific index and get element from that particular index. So we would be looking at the program which would give you a clear idea about this. But basically array is nothing but group of or its multiple elements of the same data type. Array type is fixed and cannot be changed. So in Java, when you define an array, you either give the number of elements that you can store in the array, which is nothing but the array size, or you have to give the values that a particular array would contain right when you define it. Okay. But all in all, you have to make sure that when you define an array, you give the size as well, which cannot be changed in the future. The size of the array has to be mentioned during the declaration itself. So here's an example of array. This array has around which has four subjects, which stores marks of four subjects for a student. Okay. So here you could see indexes in the white box which says 0, 1, 2, 3. It's always in sequence. It starts with 0 and it ends with n minus 1. So basically this array is of size 4, which starts from index ranges from 0 to 3. All right. The value that is stored is nothing but that's a marks in a particular subject, which is like 87, 60, 70, and 80. That's a value that's been stored into this array. Okay. We can access any of these indexes. Suppose you want to access at index 1, you could do it. You need to define upfront, you need to define the size of the array upfront. This is how it's been done. Okay, so this is how you declare a array. So we saw how we usually declare integer and stuff like that in Java, but here we are declaring array. All right, so this is an integer array, and you can see square brackets here. All right, this tells JVM that we are trying to define array of type integer. All right, so again, we use the same keyword, which is nothing but new. New keyword is used to create a particular array. All right, and here we are defining array of size 5. So this is one way of declaring array. The other one would be through initializer itself. So when you declare it, you give what are the values that particular array is holding up. In the first case, you're not giving the values, you are just defining an array which reserves some amount of memory, right? JVM would reserve some amount of memory, or in this case, it's 4 bytes, right? Array. So for integer, it takes 4 bytes. So it would reserve 20 bytes for array of size 5. All right. So in the second case, as I said, it's directly initializing the array. It's putting these values directly into the memory location. Still, it would be consuming 20 bytes, but the second variant would have the values directly initialized. So when you declare an array of size 5, the range of indexes would be from 0 to 4. If you try to access index 5, you would get this exception. Exception is nothing but a anomaly situation, right? Which or something which is not expected has occurred in your program, and Java expresses such event by throwing out an exception. You can't access index 5. So different ways of declaring array. We saw that it's with new keyword. All right, so you have new int10, which would declare array of size 10. Again, you could either have the square bracket at the end of the variable, or you could have it in between the type and the variable name. So behind the scenes, everything is the same. It doesn't do anything different for both, but these are different ways in which arrays could be declared. All right, the third one is similar to the last one, wherein we are initializing it directly. All right, we are putting this value 1, 2, 3, 4, 5 into this array. This one is again the same. So within the square brackets, you can see that you're not defining the size of the array, but you have an initializer at the end by which you express that you want to put in 1, 2, 3, 4, 5 into this array. So basically 1 and 2 that you see here does the same thing. It declares the array of size. The first case is 10, the second case is 5 though, but behind the scenes, it's doing the same thing. It's nothing different when it comes to actual reserving memory and stuff like that. It's doing the same stuff. And 3 and 4 does the same stuff. Only thing is syntactically it's varying, but what I'm trying to say is JVM doesn't do anything different to actually execute it. So the length of the array is set when it is declared, and when an array is declared, array index gets initialized. All right. So if you define an array and if you try to print the length of it, you could see that it prints out. In this case, we have declared array of size 20, and when you do x dot length, when you print it out, you could see that it prints 20. All right. So what are different types of arrays that we have? Again, similar to what we have in other programming languages, we have single dimensional array and multi-dimensional array. Single dimensional array is what we saw earlier, like you define array of integer of size 5, that is a single dimensional array. So in this case, you could see a array being initialized with value 2, 4, 6, 8, and 10. That's a single dimensional array. Since we have just one dimension, one row, right? Say for example, you want to store marks scored by a student or marks stored by a particular student, just one student, that would be a single dimensional array. All right. So say for example, the first one is the marks code in math, the second one is the science, and so on and so forth. All right. So that's single dimensional array. So now what's multidimensional array? So taking the same example of storing marks scored by a student. So by a particular student, it would be a single dimensional array. But suppose you want to store marks scored by all the students in all the subjects. If you want to store it, it would be a multidimensional array. So one particular row that you see here would be a marks secured by a student, by just one student in all the subjects. The first row would be by student 1, the second row would be by student 2, the third row would be by student 3, and so on, right? So that's where you have this application of multidimensional array. So how you access it is nothing but if you want to access the first element or the first index, it would be a of 0 0, and this would be of 0 1, and so on. So as I said, if the first column is for math, if it's a marks secured in math, this entire stuff, the first column that you see would be marks secured by all the students in math. That would be the first column. Whereas the first row is the marks secured by student A in all the subjects. So basically, this could be imagined as a table in a database, right? You have a table wherein you have rows and columns. So columns are nothing but you have fields within a table, and the rows that you have are different entries that you have within a table. So this could be imagined in the same way. So you could see how the indexes are aligned. So X increases when you go down and Y increases as you go to the right. The memory allocation of array. So for single dimensional array of type integer, one integer value takes 4 bytes, right? So now when you declare an array of size 5, you would have 20 bytes reserved. That's how memory is being allocated, right? If you have a character array of size 5, it would be 10 bytes. Since each character takes 2 bytes in Java, so you would have 10 bytes reserved upfront. All right, so that's about memory location allocation in single dimensional array. And when it goes to multidimensional array, in this case, you have like 5 elements, right? You have array of 5, which means that you have 25 elements stored within the array, right? 25 integer elements stored within the array. And each integer value takes 4 bytes for storage. So it would be 100 bytes. All right. So if you define a multidimensional array of 5 into 5, you would have basically 100 bytes allocated for it. Let's write some programs and understand more about how these arrays operate. So we have an array of 5 elements. All right. As you could see here, 2, 4, 6, 8, and 10. Write a program to access element at a specific index. Okay. So you have an array of 5 elements, 2, 4, 6, 8, and 10, and we want to access it. We want to access particular element. All right. So let's write. So I create a class. All right. I define this as array demo. So I don't give a package name here because I'm defining a class within a package. So you could see here the package came directly because I right clicked here, right? And then created a new class. So yeah, you get this particular class here. I define a main method as a type main. It would give me a suggestion, right? So this is the entry point again for this particular class. And suppose I define integer array, and suppose I define 2, 4, 6, 8, and 10, right? So you could see here we have an array defined of size 5, okay, and you have initialized it as well. So what I was trying to say is you need to have length of the array given upfront, right? If you don't do that, it would show you an error. So you can't do something like array of integers is equal to new. So you could see here array initializer expected. All right. So either you will have to initialize it or give some value to it. So if you put here 10, you could see that it compiled, right? So either you will have to mention some indexes here or the length, size of the array, or the other way is to initialize this. Okay, now you could see the compilation error has gone. So what I'm trying to say is JVM has to know about the size of the array upfront. If it doesn't know, then it would flag you with an error. All right. So we have defined this array of, let me keep it as is. Okay. So now we have defined an array of size here 5, and we have initialized values as well. Now let's try to print out values, right? So just to keep it simple, suppose it ranges, the index would range from 0 to 5 in this case. So this value 2 is stored at index 0, value 4 is stored at index 1, value 6 is stored at index 2, value 8 is stored at index 3, and 10 is stored at index 4. All right, so let's try to print 0. By the way, I want to copy it. Yeah, so I'm just printing 0, 1, and 4, and let's see what it gives out, right? So it should print 2, 4, and 10, right? So you could see here 2, 4, and 10. Now the other thing that I wanted to show is if you try to access, so let me show you what happens there, all right? So if you try to access at index 5, which doesn't exist at all, now it should give you a exception. So in Java, exceptions could be nothing but caught, and you could do something with it. So here you could see that it gave you array index out of bound exception, since 5 doesn't exist at all. The index 5 doesn't exist at all for this array. Okay, now let's define multidimensional array, write a code to find the length of row 0, right? So let's define a multidimensional array. All right, so we have a multidimensional array here. So how you define multidimensional array is something like 1, 2, 3, 4. All right, so this is a multidimensional array that you have. Okay, so we have defined a multidimensional array. The size of this array would be 2 by 2, right? 2 by 2 is the size of this array since you have two elements here, or let me put it to remove the confusion. Let me put it this way. So right now we have like 2 by 3, right? So you have like 2 columns and 3 rows. All right, so now let's print. Actually, it has to be 3 by 2 rather. Okay, now let's print the size of this array 0, right? So how we do it is again println. Now you have multidimensional array and you have 0. So 0th one refers to this 0, 1, and 2. Okay, dot length. So as you could see here, that individual row that you have within multidimensional array itself is an array. It's a single dimensional array. So multidimensional array is nothing but it's a array of a single dimensional array. Okay. So let me print here size of first array. I missed plus. So as you could see here, there was an exception. And since there was an exception, you won't have this particular statement executed since there was an exception here. So basically, to execute this particular statement, you should handle this particular exception. But we are not talking about handling the exception yet. So I'll have to comment this to pass through. So now you could see that it has printed out 2, which is your size of first array. So this is a program that we actually did right now. Create an array having many characters, write a program to copy elements from created array to another array, and also write a program to delete an element from an array. Okay, so I'll just talk about this right here. So we have an array here of characters, right? So basically when you want to delete something from an array, what you will have to do is you will have to shift the indexes, right? You can't delete something directly from an array. So what you will have to do is if you want to remove something, then you will have to shift the indexes. what happens is, suppose you have an array of 5 integers, and suppose you are deleting the second element, right? Now what you would do is, you would shift, if you are deleting the second element within the array, you would shift all the elements that follows the second element to the left, right? So the third element would become the second element, the fourth would become third, and the fifth one would become the fourth. So basically you shift it. That's how you delete something from an array. All right. So other thing is about copying elements from the array. We have a utility class, which is nothing but system. System is a class itself. So as you could have seen that when I'm printing out something, I do system dot out dot println, right? So this system, it's a utility class in Java, wherein it exposes a lot of functions within, or a lot of methods, utility methods within. So one of them being array copy. So here you have to give source and the starting index and the destination. And what we are trying to do here is copy 5. So this is how we copy from one array into another, starting from index 0. So this is copying. And the other one that you see here is about delete. So as I said, deleting is nothing but, we have a logic written here to shift the indexes to the left. So here we are trying to delete one at index 3, and we are just shifting elements after this index 3 to the left. That's how we delete something from an array. Now let's see what are strings. So string is nothing but, again, it's a data type within Java. So why do we have strings at all, right? We have array of characters, then why do we have string at all? So here's an example wherein you have a lot of loads of data. So you could imagine a role of a data analyst who has to analyze through a lot of data coming in, right? So nowadays it's like petabytes of information being processed throughout a day, right? Which would be very difficult to handle if you had to deal with character array. So that's where Java has come up with strings, which is nothing but a group of characters, but you don't have to deal with it. Java by itself has a class which would take care of this strings. And since strings are widely used within a program, you could imagine that name or anything, that any identifier that we have is mostly, we have to store it as the string. So one of the data types that's widely used within industry, or which is widely used in programming, is string, right? So Java has some kind of string management as well to make sure that programs run or make effective use of strings. Okay. So here what's been mentioned is, James is a data analyst and he's finding it really difficult to actually deal with character array to store patients' names every time. So that's where we have string. So string is solving the problem of actually dealing with character array. So Java is actually having character array, is storing characters or the characters in the string in a form of character array, but it doesn't expose it to the outside world. You can just use this class to deal with it, but you don't have to deal with character arrays. So Java string is nothing but sequence of characters. They are objects of type string class. Once a string object is created, it cannot be changed. This is a immutability functionality of Java, wherein once you write to it, you can't change the value. So this is specifically important when it comes to multi-threading, when you have multiple threads accessing a particular string, a same string. So that's when immutability helps us to make sure that, multi-threading is, it's thread safe. We call it as thread safe because multiple threads can access the same string just because it is immutable. All right. So what are different ways in which you declare a string? So you have string str is equal to new string, which you are not initializing the value of the string here, which could be any value. And you have string str1 is equal to edureka, wherein you are initializing the value of the string right away. The other one is the character array. Similar to the integer array that we discussed, we have character array as well. So immutability of the string. So why do we have immutability? One is for security. So string stores a lot of useful information, like even the credentials and stuff like that, which shouldn't be accessed by external users. So this immutability factor of string helps us to keep it secure so that no one else can see it. Synchronization. So this is what I spoke about. When you have multiple threads accessing the same string, you don't have to synchronize it. Java by itself, through its immutability feature, would ensure that multiple threads can access the same string without hampering it, or it would run as it's expected. Caching. So caching is nothing but you have a string pool. So basically, if you have two strings with the same value, it won't store it. It won't store redundant copy of it. There would be just one copy in the string pool, and both these references would be pointing to that value. If you happen to change one of these references, it would point, or it would create a new value in the string pool and point the other reference to it, sort of. So basically what we do is, why caching is required is, as you could imagine in an application, as I said, string is widely used data type, and you could have multiple references pointing to the same value of a string. So we don't want to have duplicate values stored. That's where this caching comes into picture to utilize memory efficiently. So what is string pool? As I said, string pool is all the constants that you define within the string within the application would be stored in the string pool. String pool used in Java is a pool of strings stored in Java heap memory. So we have heap memory wherein the objects are created, and that's where string pool resides as well. String pool is possible only because strings are immutable. You can't change. Once it is defined, you can't change it. If you change it, then you can't change that particular memory location. It creates one more entry in your string pool, and the reference would point to the new entry. So the actual memory location is not getting changed. That's what immutability is all about. String pool helps in saving a lot of space for Java runtime. We are breaking on the redundancy factor here. So if you have multiple strings, or if you have multiple strings holding up the same value, it won't create multiple copies of it. There would be just one value in the string pool, which would be accessed by all the references. So basically, string pool, as we discussed, is or resides in heap memory. So string is not a primitive data type. Unlike character, char is a primitive data type. String is not a primitive data type. It's a wrapper class to array of characters, right? And this is specifically done so that Java has a mechanism to manage strings well, which is widely used data type within any application or any programming language for that matter. Java strings are stored in string pool of heap area, which we already discussed. So we can see a string pool. So we have stack memory and heap memory. So when you have a local variable, when you define something locally, the reference is created in the stack, all right, and it points to the actual object is created in the heap, but the reference is created in the stack. So you could see S pointing to hello in string pool. Okay. So S is nothing but a reference to the string. Okay, so here we can see that we are concatenating, right? So this would give you a fair amount of idea what immutability is all about, right? So here we have string S1 is equal to happy, all right? And what we are printing out is the original string that is happy, right? So you could see here S1 is a reference that's been created in the stack. You have a string pool within your heap memory, which would store all the strings, all the constants or literals that you have defined here. So you could see happy been stored in the string pool and S1 pointing to it. Now you are trying to concatenate S1 with learning, right? So it's happy learning. So you could see that the memory location that S1 is pointing to is not changed, right? It's still pointing to happy. But there's one more constant that's been created in the string pool. That's a concatenation of happy and learning. So you could see happy learning also created. But what's important to note here is S1 is still pointing to happy. It's not pointing to happy learning. All right. So if you want S1 to actually point to happy learning, this is how you do. So you have S1, which has the value happy. All right. So you do S1.concat learning and you assign it to S1. All right. So you are assigning to the same reference as S1 and you are printing out S1. In this case, what would happen is, unlike the previous example that we saw, wherein S1 is still pointing to happy, you would see that S1 is pointing to happy learning. So here you could see that S1 is pointing to happy learning. So basically you move the reference from happy to happy learning. All right. So let's see what are strings. How do we operate on strings, right? So let me create a new class here, just string demo. I create a main method again. All right. Now what we do is string s is equal to Edureka. All right. So let's first print the length of the string. All right. So this is how this utility class, or this is how this wrapper class helps us. So it has all these utility methods, right? You just have to do s dot length. It would give you length of the string. So had we not had strings, and if you want to deal with the character arrays, you would have to print the size of the array here. All right. So when we run it, it should print 8. 8 is the size of the string Edureka. Let's have substring. So it's a beginning index. So suppose if you give 2, so it would give you substring from index 2. So basically we are getting substring. We are getting part of the string. Substring is nothing but part of a string, right? From a particular index. So since we have given 2 here, it starts from index 2. So you have 0, E is at 0, index 0, D is at index 1, and U is at index 2. So it starts from U till the end of the string. You have compared to, you could define 2 strings and you could actually compare them and see the value. So basically, so you could have one more string defined here, something of this sort. All right, so here we compare it. So we are doing s1 dot compare to give s2. So we are comparing s1 with s2. So it compares the given string with current string. So here you can see it has shown -1, right? Since B is 1 ahead of A. So if you have same string, it would show you 0. So if it's exactly the same, it would give you 0. You have is empty. Suppose you don't have anything within your string, you could check it whether it's empty. Is empty returns a Boolean variable, which means if it's true, it is empty, and if it is false, it has some value within. We have 2 lowercase, we have 2 uppercase. In this case, suppose you want to, there could be scenario in which you want to change or you want to change the casing. So I'll just take one of it. I make it 2 uppercase. Okay, so S1 is nothing but we have Edureka stored within, and we are, so when I run this, you should have Edureka printed in uppercase. So here we have it in camel casing, and let's see the output. So here you can see the string was converted or translated into uppercase. So similarly, you could do lowercase, which would print string in lowercase. Now we have value of is nothing but the value of a string, value of some of the data types. So you could pass integer and you could do value of, and it would give you a convert integer into string, right? So value of is a method within string which takes different data type and converts it into string. So just to give you an example, you could have like integer I is equal to 100, string dot value of, and you give I, it's converting this I into string. So it would print the same value 100, but it's converting it into string. You could replace something within the string if you want to replace particular character within the string, which could be done with replace method. So replace method takes 2 parameters. Replace is a method within string which takes 2 parameters. First one is the character that you want to change, and the second one is the new character that you want to change, replace to. Okay, so here to show s1 dot replace, I could replace e with e maybe. All right, so we are making it lowercase, and as you can see here, it's printed in uppercase e was changed to lowercase e. So that's about replace. We have contains, which again gives you Boolean type result, which says whether a particular value or particular character is present in a string. All right, so in this case, we check whether we have S2 with HELDO, and you replace D with L, which becomes hello. And now we are checking with the replaced string contains D, which it doesn't contain it, right? So it would give you false. So that's about contains. Equals is basically checks for the equality of string. It takes one argument and it compares it against the string object against which you invoke the equals against. All right. So to give you an example, so you have S1, which is edureka. Now to print it, so here we do S1 dot printing equality of string. So since it's the same, it would give you true. If had it been different, it would give you false. So you can see here it's printing both the strings are the same. You have different methods like compare, ignore case, wherein in this case we compared with case, right? If you would have had Eureka in lowercase, right? If it would have started with lowercase e, you wouldn't have got 0 here, all right? Whereas there's one more method which is s1 dot compare to ignore case, wherein it doesn't consider the case, right? So even if there's a case change, if there's a one in uppercase and one in lowercase, still it would match, or still it would give the value as 0, which means both the strings are the same. We could get some character out from a string. Okay, there's a method character at. There's ends with, which again returns a Boolean value saying that whether a string ends with a particular character. All right, so here what we are doing is we are checking whether the string P, which holds the value happy learning, is ending with U, which doesn't, right? That's the reason it gave you false. Had it been G here, it would have given you true. Now that's about strings. Now let's talk about different variant of strings and why do we need it. So there are like three variants of string. One is the string class itself. The other one is string buffer, and you have a string builder. So we'll talk about why do we need these variants at the first place. So string buffer is nothing but it's good for multi-threading. When you have multiple threads, usually it's good to have string buffer because all the reads and writes that you do on the string, it is synchronized. So when I say synchronized, there's only one thread that could access a particular method within a class at any given point. So you can't have multiple threads going in and changing the value or doing something. So basically, if you have a string within your application which is being accessed by multiple threads, it's better to go with string buffer. Or if there's a lot of not accessed as such, access is one factor, but of course, if there are a lot of modifications done and stuff like that, like with string buffer, you could append to a particular string, which cannot be done in string, right? In string buffer, you could actually do a lot of things which cannot be done in string. And just to make it thread safe, they have made all the methods that modify the string contents as synchronized so that only one thread can access it at any given point. So see, you can see insert here, right? In string, you don't have all these methods. You don't have methods to manipulate the strings in string, right? Whereas in string buffer, you have methods to manipulate the strings. So when I say strings, those are literal strings, right? Not the string class. All right, so here we have string buffer and we are trying to append something to the string buffer. So we define a class, we define string buffer. So you could have like s1 dot append, and when you see append, you could see that it appends any data type. This is the important factor in string buffer. You have a lot of utility methods within, or you have a lot of methods to manipulate the string, which you don't have it in string class. All right. So this is mutable, right? You're changing the values. Suppose I append 3 exclamation marks to it, right? So what we are doing here is we are just printing out the new string. All right. So basically you should see Edureka and the 3 exclamation marks. Yeah, as you could see here, it got appended. Right? So basically it's a mutable string. Change the value within. Insert is nothing but inserts a new character at the given position. So here we are saying that insert W at position 0. You could replace particular or replace substring with a new string. So here what we are saying is replace index starting from 0 till 2 with this new character sequence. You could delete something from it, delete sequence of it. So here we are saying from index 0, delete one character. So if you have 2, then it would delete 2 characters. So basically, when you say 2 characters, even this E would have been gone. Okay. In this case, we are just deleting one character. So basically, this delete method takes the starting index and the number of characters following the starting index. Reverse, you have like you could reverse the entire string. Okay. So just to show you, I can new string dot, if I reverse it. So basically, these are kind of utility methods which we often use, right? So you can see it's been reversed here. All right, you can see the capacity of the string. Capacity of the string buffer is nothing but I think it reserves 16 characters initially when you declare it, and it keeps on incrementing it. So it has a growth factor defined within, which you need not take care of at this point, which you need not think about it at this point, because those are internals to Java. But initially, when you declare a string buffer stores space for 16 characters, which is 32 bytes. If you have string buffer, why do we have string builder, right? So string buffer, as I said, has some drawbacks. What are the drawbacks is more about string buffer is synchronized. When I say synchronized, which means that only one thread can enter it, only one thread can process it. So basically, if you have a multi-thread application, you should go with synchronization, because synchronization has some overhead, right? It has its own trade-offs. So when you use synchronized, what happens is when you move out of the synchronized methods, JVM internally has to do some operations which takes some time. So basically, it's good to avoid synchronization, and which would make the application much more faster. And that's where string builder comes into picture. If it's a single threaded application wherein you know that you don't have multiple threads which are going to access a particular string, in that case, you should go with string builder as against string buffer, because string buffer would give you a slightly lower in performance compared to string builder. Most of the things that string buffer does is done by string builder as well, as far as the functionality is concerned, but it's not thread safe. String builder is faster, but it's not thread safe, which means that you cannot have multiple threads accessing it. All right. So to keep it simple, if you have multiple threads accessing a string buffer, then you should go with string buffer. But if you have a single threaded application, you should go with string builder, which would make the application much more faster than string buffer. Again, with string builder, the default capacity is 16. When you initialize it, it stores, as you could see, it allocated 16 space for 16 characters initially. So as far as the demo is concerned, it's pretty much similar to string buffer. As far as the outcome is concerned, it's pretty much similar to string buffer. There's no difference as such, but as far as the performance is concerned, string builder is faster than string buffer, because it's not synchronized. Okay. So you define a string builder with happy and you append learning to it. Okay, and if you try to print SB1, which is appended with learning, you will see happy learning, would see it being appended. Okay, similar to string buffer, when you delete character from index position 0 and one character from that position, you would see that the H, which is the first character, has been deleted out. So you could see that at index 1, you could insert welcome. You can see the entire string, that is welcome, being inserted between. Okay. Then you have reverse. You could reverse the entire string, pretty much similar to string buffer. So again, this one is pretty similar. You are appending, you are deleting, then you are inserting here, you have reversing here. This is pretty much similar to what we did for string buffer as far as the syntax and semantics is concerned. And the outcome is the same as well, just a performance change in terms of speed, right? So when to use string buffer and string builder? As I said, if you have multiple threads, you should go with string buffer to make it thread safe, but it would be slower as compared to string builder. Okay. String builder is specifically good enough when you have single threaded application, and it would be faster since it's not synchronized. So to make it thread safe, you have synchronization, which adds overhead to the performance, which takes toll on the performance. That's why string buffer is slower. Why to use object-oriented concepts? So let's talk about classes and objects. So classes are nothing but it has got a state and behavior, right? As you could see, you have a class and you have different objects, right? There's a phone which is a class and which has got different types of phones, right? A rotary phone, then you have a touch tone phone, and you have a cellular phone. These are objects basically, right? So you define phone, which is pretty much generic and which has got state and behavior. Class is something that is generic, that has got state and behavior. But objects is something that is an instance of a class which would have specific state and behavior. So phone is a class by itself, which may or may not have specific behavior. But you could see that the specific phones will have its own behavior. You could define its own behavior. So all these three things that you see here, three types of phones, are nothing but objects of phone class. State is something that is defined by instance variables, right? It's a class level variable, right? At the class level, you define something that gives state, and behavior is nothing but something that is defined by methods. Like calculator was a class wherein we had a add method, and add method basically gave some behavior to the calculator class, right? So what are attributes? So you have a class and you have attributes. Attributes are nothing but a property of an object, and in Java this is defined by your instance variables. Basically, class will have properties, which is nothing but the state, which would be defined by instance variables. And you could imagine every instance will have its own set of properties. It won't be the same, right? In terms of the phone that we saw earlier, there were three different types of phones. You could imagine that it would have different properties, right? It's not the same. So what are the naming conventions in generally used at the industry level for Java? So this is not something that is actually taken care by compiler. So even if you don't follow these naming conventions, still the compiler would pass through. But these are best practices, or this is good to have thing in the industry. Conventions is more about to keep everyone on the same page and make it easier for other developers to understand more, right? Or keep things simpler. So that's why we have conventions. If we wouldn't have conventions, then people would prefer to write in their own way, which would make us difficult to understand. All right, so for class name, it should start with uppercase. As we saw in all the examples, you would see that I have always used started with the uppercase, or it's rather camel casing. So in this case, you could see string buffer demo, right? So it starts with uppercase, you have B, which is again uppercase, you have D, which is again uppercase. This is nothing but camel casing. It starts with uppercase. Basically, it follows camel casing. Interface name is again similar to class. It starts with uppercase. You have method name, which should be lowercase always, which should start with lowercase, but you could have it follows camel casing, but it has to start with lowercase. So main is a predefined method within Java, right? So you could see main starting with lowercase. Or I created add, right? Add is again, you could see uppercase. If you would have, say, for example, add numbers, you would have something of this sort, add numbers. If you want to append numbers to it, it should start with uppercase. So basically it's camel casing, but starting with lowercase. Whereas class name, it's a camel casing which starts with uppercase. Variable name is again camel casing, which should start with lowercase. And constant is always like it has to be everything in uppercase. So basically, if I define a constant final string, I would write something like this. Okay, so and if you want to add more words to it, it should be like this underscore. So it should be separated out by underscore. All right, so these are the conventions that's followed in industry by Java community. So mostly, even if you go to the source code, if you want to see something, dig into the source code of Java, you would see same naming convention being followed. Types of variables, we spoke about the types of variables. Again, to brief you through, we have local variables. Local variables are nothing but the variables that are defined in a method. So if you define something within a method, that's local variable. So arg100, or suppose I define anti-local var is equal to 100. So this is a local variable, right? If you remember, this is within the scope of a method. Once the control goes out of a method, your variable is no longer accessible. And also it gives space for the JVM, for garbage collector, to kick in and clean up this particular memory space. Instance variables are nothing but it's defined at the instance level. So here, for that matter, this constant is also instance variable. All right, so I can define integer. Variable starts with lowercase and it follows camel casing. So this integer is nothing but an instance variable. It's at the class level, right? When your class is loaded, when you refer to this particular class, you would have your instance variable initialized by Java. So instance variables are declared in a class, but outside a method, constructor, or any block. Okay. Class variables are nothing but static variables, and it is one copy per class. So as against instance variable, which is one per object, whereas static variable or class level variable are it's just one per class. So if you define static, this is just one per class, and this could be accessed directly using calculator dot constant example. You would be able to access it. But for instance variable, you need to have an object created. This is non-static, basically non-static instance variable. So one of the reasons why you need to access instance variable is because different instances might have different values for a particular instance variable, right? I could define calculator one, right? Let me put it as calculator, and we have like normal calculator. You could have one more class which is like scientific calculator. It's one more object. Now normal calculator can have its instance value as 10, and scientific calculator can have its instance value as 100. You have different values, but whereas in static, since it's one per class, it's not at the object level. So you have demo D is equal to new demo, which is an instance of a class demo, and you print message, right? D dot print message, and it should print this message. So basically there's a class demo which has got a method print message, and we are trying to invoke that message from the main method. Okay, let's talk about the constructor. Constructor is nothing but when you invoke new keyword, new calculator, there's a constructor, implicit constructor for each class, which is without any parameters. So we'll talk about that, but when you do new calculator, basically there's a method which could be used by the programmers to initialize variables. If they want to initialize something, so for each instance, if you want the same value for an instance variable, you could initialize it within constructor. So basically constructors are for initialization, or if you want to do some kind of pre-processing, right? On invocation, if you want to initialize something or do some kind of pre-processing, that could be done through constructor. Constructor is used in creation of an object. It is a block of the code used to initialize an object. So when I say initialize an object, it's nothing but initialize some property or variable within your class. Constructor must have the same name as the class it is in, and it does not have any return type. So unlike method, which has got a return type, constructor won't have a return type at all, because what we are trying to do through constructor is just to initialize objects within, but you can't return something out of it. So basically, constructor is a special method which you don't have control over. You're not doing anything within it. You're not trying to actually return something out of it, right? You don't have control over its invocation. It's done by JVM itself. JVM calls this special method when you invoke new or when you create instance of it by using this new keyword. Constructors are of two types, default constructor and parameterized constructor. So when I say default constructor and parameterized constructor, this is nothing but, so I'm defining a constructor now, calculator. As I said, it has to have the same name as the class. Okay, so this is a constructor. And as I said, this could be used for initialization of variables. Say I initialize this to 200. So for all the objects, you would see this being initialized to 200. That's the initialization. Okay, so I have created two instances of it, two instances of calculator class, that is normal calculator and scientific calculator. Let me do normal calculator dot instance variable. Okay, so here we are printing the value of the instance variable. Let me copy the same thing again, but in this case, the second case, I would be, as you could see here, we have a constructor. I defined a constructor here, constructor for a class, which is initializing the instance variable to value 200. So as and when you call this new calculator, a new instance of calculator would be created. The first thing that would be called is this constructor, and which would initialize it. So basically what we are trying to do here is, we are right after the construction of this particular object, we are going to print the values of instance variable to see if it assigned 200 to it. So here you could see the value 200 being printed out. So basically, if I wouldn't have constructor, then the value wouldn't have been 200. So let me comment out this one. This is how we comment in Java, by the way. This is a block comment which starts with slash and asterisk, and which ends with asterisk and slash. So I commented out that one. I commented out the constructor, and you would see the value being initialized to 0. So you could see value being initialized to 0. All right, so that's what constructor is all about. Now this is a default constructor. You could have parameterized constructor, which is like integer. You provide some value, right? And you assign this value to variable. So instead of hard coding this value of 200 for the instance variable, you could pass on some value during the construction of the object. So basically what we are doing here is, I pass 30 here and I pass 40 here. All right, so I'm passing 30 and I'm passing 40 to the constructor. And as you could see here, we are initializing the instance variable to that value. So basically for normal calculator, it should be 30, and for scientific, it should be 40. Yeah, as you could see here, you have 30 and 40 being printed out, and this is the parameterized constructor. That's what this default and parameterized constructor, and that's what it is all about. So default constructor is you don't even have to specify any constructor. So I commented this calculator constructor. Still implicitly there's a constructor put in by JVM, which is the default constructor. So it's not mandatory to have constructor each time unless you want to initialize something. So what's the difference between constructor and a method? Constructor must not have a return type, whereas method may or may not have a return type. Here you could see that unlike the methods add integer which return something, this doesn't say anything. This doesn't return anything because we are not doing anything within it. We are just initializing it, initializing some instance variables, right? Constructor name must be same as the class. So this is a contract. This has to be followed. Constructor has to have same name as the class. Since you are not invoking the constructor by yourself, it's done by the JVM. You don't have control over invocation of constructor, and you have to follow the naming pattern that Java recommends to or Java forces us to. You have to make sure that constructor is given the same name as the class name, whereas method can have any name. As we saw the add method, you're free to use whatever method name that you want to. Constructor is used to initialize the state of an object. We saw the instance variable being initialized within the constructor. Method is basically it gives some behavior to a class, right? We saw add method, which is giving some behavior to the calculator method, which is nothing but adding up two numbers. Similarly, you could have multiply, you could have divide and stuff like that, which adds more behavior to it. Constructor is invoked implicitly, so you don't have control over invocation of constructor, which is done by Java itself. When you try to instantiate a class or when you use the new keyword, it's implicitly invoked by Java, by JVM. Whereas method, you have to invoke it manually. So basically, when you do this, constructor is called by itself. Whereas when you want to call add numbers, you have to invoke it explicitly. How does constructor work? The moment object of a class is created, the constructor of the class is called, which initializes the class attributes, right? So we saw about this. So when you use the new keyword, JVM by itself would give a call to the constructor, which could be used for initializing instance variables within your class. So type of constructors, there's default constructor and there's parameterized constructor, which we already spoke about. The constructor which is created by the compiler without any parameters is the default constructor, and the constructor with specific number of parameters is called parameterized constructor. So here we spoke about this already. So we have integer value, right? This is a parameterized constructor since you are passing parameter to the constructor. Whereas if you don't define anything, Java by itself. So in this case, you could see that we didn't have a constructor for this class, right? Array demo, we don't have constructor for this class. So Java by itself puts a default constructor for array demo, which is known as default constructor. So it's not mandatory that you need to have constructor every time since Java takes care of it. That's the differentiation between default constructor and parameterized constructor. We use parameterized constructor for passing values to the constructor and initializing something based on the value that's been passed in rather. So the default constructor is used to provide the default values to the object like zero, null, depending on the type, right? When I didn't have any constructor at all, for a moment, I'm going to comment this. So this is a line comment. When you put two slashes, it's a line comment. Okay, it's commenting just this particular line. There's a block comment and there's a line comment. Block comment is slash asterisk and ends with asterisk slash, whereas line comment is two slashes, forward slashes. Okay. So basically, I'll comment out these constructors as well. All right, now we have this calculator class. Now let me print the value of the instance variable. Value of instance variable initialized by default constructor. All right, so we don't have a constructor at all. So that's what I'm trying to say here. I commented out these constructors, right? So we don't have a constructor at all. And when you create a new calculator, JVM by itself would have a default constructor, which is used by JVM to initialize variables within. So you would see this instance variable as value as zero, because that's what the default constructor does. It assigns some value to it. It has like specific values. For integer, it's zero. If it's a class, it would be null. So you could see the value being printed as zero. If it's a class, it would assign value null. So in this case, you have string, right? And you could see zero, null, depending on the type of instance variable that we are dealing. We saw how we passed parameters and initialized it. Constructor overloading is just like method overloading without return type. Constructor overloading in Java is a method of having more than one constructor with different parameter list. Like we defined add, we had two add methods, and now I have renamed this to add numbers, but basically this was add method, right? So you could have multiple methods with the same name but different parameter list, which is known as overloading. Similarly, for constructor, you could have the same paradigm. So basically what we are trying to do here is we have a constructor with one parameter that's integer. I'll define one more constructor here with two parameters. So we define one more parameter here, and I say, for example, I put something like this. So we are adding up these two parameters and putting it into instance variable. Okay. This is constructor overloading. So here you have single parameter being passed. Here you have multiple parameters being passed. So based on whatever you pass here, suppose I say 10 and 20, or I say, so on construction, you should see 130 as the value of the instance variable. Okay, as you could see here, you have the instance variable initialized to 130, which is nothing but addition of 110 and 20. And you could have something like this, just 110, which is also okay because you have a single this thing defined as well. Constructor taking a single value as well. And in this case, it would be just 110. So constructors are nothing but methods which helps in construction of object. All right, so you get 110 here. So constructor overloading is in Java is a technique of having more than one constructor with different parameter list. So we had a demo about it. As I showed, there were multiple constructors, one with one parameter and the other one with integer parameters. And during runtime, based on whatever you pass, a particular constructor would be called. In this case, you could see that in the first case, which is shop S1, you could see the first constructor being called, which has two integers as being passed. Whereas when you create object S2, which has two integer parameters and one string, you could see that second constructor is being called. Now, what's constructor chaining? So constructor chaining is the process of calling one constructor from another constructor with respect to the current object. The real purpose of constructor chaining is to pass parameters to a bunch of different constructors, but the initialization should be done at a single place. Constructor chaining can be done in two ways within the same class from the base class, and constructor chaining occurs through inheritance. So basically for constructor chaining, there are two keywords that we have. So one is this. This itself is a keyword in Java, this, THIS. This is a keyword, and this super keyword. Let's see how we do it for this particular constructor. I have this constructor which has this value, right? So instead of doing this directly, what I could do is, so here I was initializing this value directly to the instance variable. What I could do through constructor chaining is I could do this, and I could pass the value comma 0. So basically you're chaining here, right? You could see that what I'm trying to do here is I'm trying to invoke this constructor from this constructor. That's what the chain is all about. So when you say this, It tries to find constructor within your class which takes two parameters, two integer parameters, and this is the one it finds out, right? It has two parameters. And basically what we are doing is we are keeping the second parameter as 0, which means it would initialize the instance variable to whatever value you have here, right? This is what constructor chaining is all about. It's more about calling constructor of the same class within the constructor of the same class. So basically from this constructor, you are giving a call to this constructor. That is constructor chaining. Super should be the first, I think. It gives a call to the super constructor. So you have a subclass and superclass, right? What you do here is you give a call to superclass. For constructor chaining, I think this should be good enough, wherein you use this keyword to call constructors within the same class. You basically chain them together, right? We have demonstration on constructor chaining here. When you create student, you could see there's a constructor without any parameter, and we could see this Megan being called. So basically what we are trying to do here is the default name would be Megan, right? So, and again, we have one more constructor, which is overloaded constructor, which takes name. And in that case, it would give a call with the specified name and mark as 70. So basically 70 is a default marks that we are assigning, and Megan is the default name here. If you don't provide name, it would be Megan. All right, so this is what constructor chaining is all about. Static keyword. Static keyword, again, we have spoken about in a couple of instances, but I'll just walk you through this slide again. The static keyword is used for memory management. Static is non-access modifier used in Java, accessible, applicable for blocks, methods, class variables. Static keyword is used to refer the common properties of an object. So as we spoke, it's at the class level, it's not at the object level. We have it common across all the objects, right? When the static keyword is used to declare any parameter, then memory is allocated only once for that parameter. So in this example, we could see that since it is one per class, so you would have this constant example defined just once, right? It would be allocated just once. Whereas in the non-static ones, like this instance variable, you would have memory allocated for each and every instance. So basically, for this instance, you would have memory allocated for this instance variable. For again, this normal calculator that we had earlier, you would again have a memory allocated for instance variable. All right, so it's one per object, whereas the static ones are one per class. So yeah, memory is allocated only once for that parameter. All right, so here we can see that we have a static string company which has some company name put in there, and we are just displaying it, right? We can see that we are displaying ID, salary, and company. And you could see that for both the instances, for E1 and E2, you have two employees here with ID 25 and salary 25,000, and we have employee E2 with salary 30 and with ID 30 and salary 3,000, right? So we are defining two instances of employees, and you can see here we are not passing the company name as a parameter to the constructor, right? Still, when you display it, look at the output at the right side, you can see that it has displayed 25,000 and SRT traders. The company name came by itself because it's one per class. So what we are assuming is this class is basically designed just for one company, right? That is SRT traders. So all the instances of the class or all the employees that you create here, all the instances of employees that you create here will have the same company name that is defined here, since it is one per class, right? Whereas their ID and salary would be variable, which would differ as per the value that you pass to the constructor. Here we can see that company is a static variable. It allocates memory only once. So here it could be seen that you, as I mentioned earlier, you have reference variables being created out in the stack. And in the heap memory, you could see values being stored. So ID is 25, salary is 25,000. For E2, ID is 30 and salary is 3,000. And you can see the static variable. So basically, static variable is stored in a different space, which is permanent generation memory. That's where the static variables are stored. So a method could have static as well. When a method is static, you need not create instance of a method to call that method, instance of a class to call that method. Pretty much similar to static variables, right? So basically, I can have one more static method here. So say, for example, I have private static. All right, so what I was trying to say here is you could have calculator dot, and you could directly call the display method. So you did not have instance of a class created. It's at the class level. This is at the class level rather, right? One per class. Let's talk about this keyword. This keyword is used as a reference variable to the current object. So basically, what it is trying to say here is, so if I want to print something here, let me print the instance variable, right? So within the add method, what I'm trying to do is I'm printing the value of instance variable within add numbers, right? So I'm trying to print the value of the instance variable within add numbers, which would be basically, this is where we are calling add numbers. So basically it should be 110, right? When we have such scenarios wherein we refer to an instance variable within a method, we could see here printing the value of instance variable within add numbers gives you 110, right? Implicitly what happens is it puts this dot here, this dot instance variable. All right. So what we are trying to say is the instance on which the add numbers was called, on the same instance, whatever the value of instance variable is, just print that thing out. So this is implicitly put in here. You need not use this keyword. This keyword is usually used when you have something like this, right? When you have instance variable. Suppose you have something of this sort, right? One of your parameters is same as the instance variable, right? So you want to differentiate which is the instance variable and which is this variable, right? So that's when you use this. When you say this dot instance variable, this is referring to this instance variable, and this instance variable to the right hand side is referring to this one. All right. So that's when you have to explicitly put this, or in other cases, it's done by the JVM itself. You did not take care of it. All right. So this can be passed as an argument in the constructor call. This can be used to invoke current class method. This can be passed as an argument in the method call, and this can be used to invoke current class constructor. This could be passed basically if there is one more. So say for example, you have something of this sort, which is pretty vague though, but add method taking calculator as its parameter. Okay. So I'm just trying to demo, you could actually take calculator as an argument for any of the methods within. All right. So you have an add method which takes calculator as its parameter. All right. So here, say for example, within this method, don't think about the logic. It's not logical though. I'm just trying to show you it could be done, right? So I have add and I put this. Within your method, you could pass as an argument. You could pass this as an argument. So basically you are invoking this one. So now if I print it, you can see in add numbers, you have this method being called. So yeah, here you can see printing out the add method taking calculator as its parameter. So basically it's calling this on by passing this. So yeah, we spoke about the constructor earlier. We saw how this could be used in the constructor. And one of the use cases, as I said, here you could see that similar to the example that I spoke regarding the instance variable, you could see the parameter, the name of the parameter is roll number, which is same as the name of the instance variable. This one is pretty much similar to that. You could see that the name of the parameter that is passed to the constructor is same as the instance variable name. The roll number to the left hand side is nothing but instance variable within the class info, whereas to the right hand side it's a roll number that is passed as an argument to the constructor. Similarly, for the name, you have this dot name, which is referring to the name, the instance variable in the class info, and to the right hand side it's a parameter that's passed to the constructor. That's a typical use of this. So we are creating a message here, and you can see that we are giving a call within the constructor. This is within the constructor actually. So we saw this in the previous example. Basically, this is what it does, right? This value of 0, that is what this is doing. Within the constructor, you have this, and you are giving a call. So in this case, this Annie would give a call to message string n and would print it out. So how does it work? The main function is executed. So again, this is a sequence in which the things execute behind the scenes. The main function is executed first. When an object of the class is created, a default constructor is called. Okay, in this case, the one without parameter is called, right? Then you have this dot Annie, which is nothing but you're giving a call to the constructor within the same class, but with the parameter Annie. So the JVM would check whether you have a constructor with parameter as string. So it finds it and it would give a call to that constructor, which is nothing but the constructor that you see here in a blue block, right? Then it would, similar to any method, after the method invocation is done, it comes back to the calling method, right? So after this Annie is called, it comes back here, then it prints welcome to Edureka. And once this is done, it would go back to the main method. In general, what happens is whenever a method is invoked, the local variables and everything is pushed onto the stack, similar to C, right? In C also you have a calling stack. So your local variables go into the stack, the calling method is invoked. After the method is being invoked and is completely done, it would come back to the stack and start off from where it had left earlier. So typically how the subroutines and everything work in programming language, that's how it's done in Java as well. So that's why we have calling stack. So that's a sequence of execution that happens. So let's start off with object-oriented programming concepts. This is pretty much generic. This is not something that is just for Java. So this is an object-oriented programming concept, which usually all the object-oriented programming languages use it or adhere to it. So we have inheritance, which we'll be covering up in the topics to come. Polymorphism, which is we have like static polymorphism and we have dynamic polymorphism. Cover it up in details in the coming slides. We'll talk about what is abstraction and also how Java has encapsulation or how Java is aligned towards the encapsulation feature of object-oriented programming. So let's start off with inheritance. Just to give you an analogy, you could think of inheritance anything that is derived. You have some superclass or you have something from which other subclasses are derived. When you have some feature of your parents, we say that you inherit it, right? Because you have got it from your parent. So you have a parent. So this could be analogical to something of that sort. Maybe your looks is inherited from your parents, sort of. That is exactly what inheritance is all about. You have a parent class and you could have subclasses out of it. And this subclasses would inherit the features or inherit state or the behavior, I would say, of your parent class. So to give you an example, as you could think of vehicle, right? Vehicle is generic thing, which could be a superclass. So vehicle could be thought of as a superclass. Now there are subclasses to vehicles. You have bike, which is a type of vehicle. You have car, which is a type of vehicle. You have buses, which is again a variant of vehicle, and truck, of course, is again a vehicle. So basically, this defines is a relationship. Bike, if you read it out, you could clearly say that bike is a vehicle, car is a vehicle, bus is a vehicle, and similarly, truck is a vehicle. So basically, this is something like it defines is a relationship. So let's see about how actually this classes or the subclasses inherit from the parent classes. Just to read out, inheritance is a powerful feature object-oriented programming through which one object acquires some or all properties and behavior of parent object. So as I said, it's a is a relationship. So is a relationship is represented in Java through inheritance. It could also be seen as a parent-child relationship. So subclasses are actually childs of parent classes. In the previous case, you have bike, which is a subclass of superclass vehicle. So vehicle is a superclass, and henceforth we would be talking in these terms, or we would be using these terminologies. So just wanted to be sure you get it. So vehicle is nothing but a superclass, and bike would be henceforth referred as subclass. Child classes would be referred as subclass. So you have method overriding. What do you achieve by inheritance is more about method overriding to achieve runtime polymorphism. And the second thing is code reusability. As I mentioned, the subclass would inherit properties and behavior from your superclass or your parent class. So there could be some method defined in your superclass which need not be redefined in your subclass. It inherits by itself. That's the property of inheritance. If it has got a common behavior, like say you have two kinds of calculator, different types of calculator, the example that we spoke about yesterday. There could be a parent class calculator which is adding numbers as is. You provide two numbers, it adds up and it gives you. Maybe this add behavior could be added into the calculator class. Now, suppose there's a subclass of calculator wherein you have this scientific calculator or something, which is modifying this behavior of, or which is using the same behavior of add, right? Basically, though a normal calculator or a scientific calculator will have the same add behavior, adding up two numbers. Whatever you send it as a parameter, it would add it up and give you the result. So basically, you would define this add in the calculator. In the scientific calculator, that would be the subclass of your calculator. You need not redefine this add method. It would inherit from the calculator method. So that reduces code redundancy, or it helps you in code reusability. You need not redefine the add method again. We have a lot of slides to come about method overriding and method overloading. So I won't talk it right away. This is inheritance. You have a manager class and you have like employee, which is extending manager. So what we are trying to show here is e.salary. As you could see here, there's a salary property in a manager, and this employee 2 is extending manager. And we could see here that employee 2 inherits salary property. Though it doesn't have a salary property, we are able to access the salary property from employee 2. So let me give you an example. You just have to click on create new project and give some project name. I'll give Edureka module 3. So it opens up a new window. You could go to the source folder and you could right click on it and create a new class. So basically I'll do one thing. I'll create employee class. I'll follow the same example that's been mentioned here. I create com.edureka.manager class. So com.edureka is nothing but the package name and manager is your class name. So now I define a property here, say salary in that case, right? Suppose I say, maybe I'll put it as long salary. So I define a property within your manager, which is salary. Now I define one more class. So you could either define it within the same file or you could create a new class. For simplicity, I'll create a new class. It'll create employee. So it created an employee class within com.edureka package. Now let's do main, which is your entry point for the program. Now, as you could see, I haven't defined salary within employee. The first thing that I'll have to do is, we are talking about inheritance. So employee extends. This is a keyword used for inheritance. So employee extends manager. So now you could see there's a property which is salary, which is defined in the manager, and there's employee, which is the subclass of manager. And let's see if salary is accessible to employee, which is a subclass of manager. So I define employee, emp is equal to new employee. This is how we create instance of the class using new. Now let's see if, just for simplicity, I'll give this emp dot salary. You could see that, right? Just to be sure, I print out. So as we can see here, salary, though it's not defined in employee, it has been inherited from, rather, from your manager. We can have one more instance created, which is like manager is equal to new manager. This is the instance of manager class now. I do manager dot salary is equal to salary of manager is, we are just printing it out. So what we have done here is, again, I repeat the same thing. So we have a manager. Within manager, we have defined a field salary, and we have employee, which is extending manager. And in the employee class, we don't have the field or we don't have the property salary defined here. But we could see here in this example wherein we created the instance of employee and we are accessing salary property from here, though it's not defined specifically in employee. It's been inherited from your parent class, that's manager. And manager, of course, has salary field, which has been accessed out here, and we could assign some value to it. I run the program, it should compile and create a class file out of it, and it runs the class file using JVM. So yeah, as you could see here, it's printing out values for salary of employee and manager as well. So that's about inheritance. It's inheriting the property salary from parent class. Now, what are different types of inheritance that we have? There's single inheritance wherein you have a parent class and you define a subclass out of it. So similar to what we spoke, we had a manager class and we had employee class, which was inheriting manager. That's about single inheritance. You can have hierarchical inheritance wherein you could have multiple classes inheriting from a same class. So you could have A and B inheriting from a single class. You could have multi-level inheritance wherein you have one class inheriting from another, and again you could have subclass of the subclass. Parent class, you inherit it or you subclass it or extend it, whatever you say. So there's one level. So you have a child class now. You could have one more subclass of this child class. That's what multi-level inheritance is all about. So as we go through the example, it should give you a clear idea about what I'm talking about. So single inheritance, so we have vehicle and we have bike, which is extending vehicle. So this is similar to what we defined here. So what we did here is single inheritance. You had a manager and you subclassed it, and this is just single inheritance, one level. So what is hierarchical inheritance? So you have a vehicle and you have two subclasses created out of vehicle. So there are two childs of a parent class. So this could be pretty much similar to a parent having two kids, right? There could be two kids and they inherit some property from your parent. So it's pretty much similar to that. So you have a vehicle class, which is your super class, and you have subclasses to it. So let's see how this works. So I create a vehicle class, which is the super class. I have a vehicle class, and say vehicle class has a property which says integer, say number of wheels. This could be one of the property of a vehicle class. You have, say for example, you have the mileage. So these are common properties that you have in vehicle. Say you have motion. Just to add a behavior to this particular class, I define method move and I just print this thing out here. I define two properties here for vehicle class, which is number of wheels and the mileage, and add a behavior to the class by introducing method, which is move, which is nothing but I'm just printing it out. So ideally you would have some functionality written within, or you would have lines of code written within. Just because we are talking about inheritance, just to show the properties and behavior is been inherited by the subclass, for simplicity's sake, we don't have any logic written within move. It's just printing it out saying that, just to indicate that there's a move method within the vehicle class is being called. We are just printing it out there, but in reality, as I said, there would be actual logic written within. So now I define car class and I define bike class. So now I say that car is extending, which is nothing but subclass of vehicle. So remember we said is a relationship, car is a vehicle. So what we are saying is we are subclassing or we are inheriting properties of vehicle into car. Suppose I change the property of any method within, or say I can have its own movement when car class. So basically we are overriding it. What we are trying to do is we are trying to, whatever method you had within your car class or the vehicle class, you are overriding it for the car class. You are trying to change something. Similarly, in your bike class, you could override the move. So first thing that we'll have to do is bike should extend your vehicle. So bike is a vehicle, we are extending it. Now we are again overriding this move method to say move in bike class. So now basically we can have say one more just for simplicity's sake. We have just a class wherein you would write the main method. So this is generally a practice wherein such classes are called as client classes, wherein you have a main method and you do something with it. I just call it as automobile management class. So you have a main method. So suppose you want to change number of wheels for a car. So what you would do is car is equal to new, or it won't be car, it would be like, suppose I put Mercedes is equal to new car. I create Mercedes, I create BMW is equal to new car. So now what we do is I want to override the property that is number of wheels for Mercedes to 4. Similarly, I could have a bike class, say R1 is equal to new bike or something of this sort. You could have Ducati is equal to new bike. So this is just to give you an idea of how we have classes and objects, right? Now you could imagine what objects is all about. So Mercedes is a object of car, BMW is a object of car, R1 is a object of bike, and Ducati is again an object of bike. So now I could override the properties here, say number of vehicles as 2. So yeah, this is what it is all about. This should give you some idea about how we use Java. You have a class, you have subclasses, then you kind of create objects and you could override the properties within. And you could change, when I say override is nothing but you could modify the values within your subclasses. And similarly, you could change the behavior. Vehicle by itself would have some behavior defined, but Mercedes and BMW, which is a car, could have its own kind of behavior, which is not inherited from parent. You are overriding it. When you say this could be analogical to something like kid doesn't have the same features as their parent. It is something like it's been overridden, right? It's peculiar to that particular kid. And that's what this is all about. So you could override it. Now let me print move, or let me call the move method on BMW. So you could see a move method. And when I run it, it should show move method in car class, since it's a move method called on car. BMW is an instance of car. So this should give you some idea about how are we inheriting properties and behavior from parent class. So here we can see that move in car class. So again, you could define your own method within your subclass, which is not something that is inherited from your parent class. So BMW by itself or car by itself could have something like say turbo, which is not in vehicle maybe. This is specific to car. So this is what we spoke about is hierarchical inheritance. Now let's talk about multi-level inheritance. So basically it's nothing but say you have a superclass category. So let me use the same example. You have a vehicle class, you have a car, which is extending vehicle. Now I define one more class, which is nothing but superclass, supercar, which is extending car. Basically, I can put this turbo in supercar rather. That would make more sense. This is like kind of multi-level. So I'm putting this turbo here in supercars. You have a vehicle class. You have a car, which is subclass of vehicle. You have a supercar, which is subclass of car. So all the properties that you have in vehicle class could be accessed in car as well as supercar. That's what we want to see here. So you could have something like, say, change wheels, which is void, which is not returning anything here. I just want to show you that we can still access number of wheels here. Though it's not defined in car or supercar, But in vehicle class, you could actually, it is still visible here and you can modify it. That's the beauty of it. Again, to brief, you have a vehicle class, you have a car class, which is extending vehicle class, you have a supercar class, which is extending car class. So basically, there's a multi-level of inheritance, and all the properties and behavior that you have in vehicle class would be visible to car class as well as supercar class. And supercar class can access properties and behavior that is there specific to car class. So what I'm trying to say is, if you define a new method here, so I just mentioned here behavior specific to class to car, so there's some behavior that is specific to car that we have defined within the car class. Now supercar class can access this one as well. So you could see here, you could access behavior specific to car as well. If you look it as a tree, this is a leaf node. This is supercar class can access everything from vehicle and car class. Whereas car class can access everything from vehicle class. But it's not the other way around. Car cannot access something that is specific to supercar. There's a turbo method that we have put in into the supercar class. Now, if you try to access turbo from here, you won't be able to access it. All right. So it's not the other way around. So you cannot access something that is specific to your subclass in your superclass. Whereas you can access anything that is there in your superclass into your subclass. So it's a one directional flow from superclass to subclass. Now let's talk about has a relationship. Has a relationship is nothing but you have properties within your class, which is has a relationship. All right. So say for example, employee, right? We define the employee class, and employee would have an ID specific to an employee, and it can have salary and stuff like that, which is has a relationship, which is nothing but employee has a ID sort of, right? So a department in a class, let's talk about this example. A department in a college has several professors. Without existence of departments, there is good chance for the professors to exist. Hence, professors and department are loosely associated, and this loose association is known as aggregation. So one can exist without other, which is loose association, and such thing is nothing but aggregation. So here you could see employee, here you could see name class itself, which has got first and last name. So basically you have a name class which has got property as first and last, and which is nothing but the first name and the last name of any entity. It's not associated with anything. Right now it's a different entity. Name is a different entity which would have first and last name. Now there's an employee info class which has got ID and which has got name. So you can see name here. This name property is nothing but the instance of name class that is there at the left hand side. So this is has a relationship. This says that employee info has name. So basically this is what it is. When you talk about has a relationship, it's containment. It's basically you have class as a property in a class. So in this case, name is a property within your employee info. And similarly, this name could be used somewhere else as well. It's not that it has to be used just in employee info. That's a kind of detachment they have, right? It's not tightly coupled, it's loosely coupled or decoupled. So basically you have name, which is altogether a different entity defined as a class, which would have first and the last name, and you would have an employee info, which is containing name, which has name. So this is has a relationship. And also to give you idea about has a relationship, it's not just it has to be object, right? So vehicle has number of wheels. Vehicle has mileage. This could be thought of as a relationship. So let's talk about polymorphism now. When one task is performed by different ways, then it is called as polymorphism. Poly is multiple, morphism is forms. Basically, that's the meaning behind it. So multiple forms, that's what polymorphism means. And when one task is performed by different ways, then it's called as polymorphism. This person, which is a superclass, you have a subclass, student is again person, millionaire is a person. These are superclasses. So you have a person class, you have a superclass student and millionaire. You have a behavior which is nothing but pay bill and which would be specific to both of them. So as we move on, you would get much more idea about the different kinds, but basically you have multiple forms. That's what polymorphism is all about. So what is method overloading? So we spoke about this yesterday. If you remember, we spoke about constructor overloading, wherein you had multiple constructors defined. One was integer, integer, and the other one was like it was taking three parameters, integer, integer, and three integers, right? So basically, this is what method overloading is all about. You have the same name of a method, but you have different number of parameters passed to the method, or you have different type of parameters passed to the object, to the method, and based on that it would understand which is the method that needs to be called. So suppose you have add with two integer parameters defined and you have add with three integer parameters defined. Now when you invoke add method on a particular instance of calculator and you pass two parameters to it, it would appropriately call add method with two parameters. And if you pass three parameters to it, it would call one with three parameters, or it would resolve it during the runtime, which one to be called. Rather, it's not overloading doesn't happen during runtime. It's done during the linking or the resolving operation happens during the compile time itself. That's why it's static polymorphism. Method overloading is nothing but static polymorphism. So return type is not taken into consideration when it comes to method overloading. It's just the parameters that a particular method takes. So Alex wants to write a code which can be used to find out the area of triangle as well as of circle. So generic code which would have area of triangle and circle. So such are the instances wherein you could use method overloading. So what's the thought behind this? I want to find area of both the shapes. Here area is a common method. It's there for both the shapes. It's there for rectangle, it would be there for square, it would be there for circle, and so on and so forth. So basically you would have a shape method which would have area, which is a common method. So instead of writing two methods of different names, I'll write area as a method name for both shapes and I'll pass different arguments according to the respective shape. So instead of defining multiple area methods, you would have just a generic area method defined in your shape class and your subclasses would overload it as per the type of shape. So here we can see that there's area class, there's the area method, which is taking integer. Since it's a triangle, it's base and height. So it's taking base and height as parameter. So Java doesn't understand base and height. This is user defined, by the way. It understands there are two integer parameters passed to the area. Whenever there are two integer parameters passed to area method, this one would be called. The other one is, again, we have one more method, which is area, which is by the same name and which is taking just one integer parameter, which is radius. So this is supposedly for circle, pi r square. So during runtime, when you call it, so I'm not repeating this exercise again because we did the same thing yesterday, if you remember. We kind of had multiple add methods in the calculator and we saw that it was getting resolved to the proper one based on the number of actual parameters that you pass. So I'll just read through the slides to make you give more explanation on this, but it's pretty straightforward. So here you have area method, which is taking 4, 6, which is nothing but it would get resolved to during compile time. This particular area method invocation would get resolved to this one since it is taking two integer parameters. The second one is taking just one integer parameter, which is 5. So it understands that it has to call this area method, the second area method that's been defined in method demo, and it will call it accordingly. So here you could see that when you run this particular program, you could see that the first one resolved it to triangle and it said that the area of triangle is nothing but 4 into 6 into 0.5, which is nothing but 12. The second one goes to pi r square and it gives answer as 78.5. So you could see there are two different invocations done based on the number of actual parameters. Now let's talk about type of parameter. The method overloading can happen on type of parameter as well. So you could have multiple methods with the same name taking same number of arguments but different data types. One could be taking integer as a parameter, the other one could be taking string as a parameter. And during runtime or during compile time itself, it would resolve that, this one should be resolved to this invocation and the other one should be resolved to the other one. So basically it tries to resolve based on the parameter, based on the data type of the parameter that you pass. So here's the example wherein you have two different methods. I'll take this one, say for example, I define public integer, so it's a dummy value to be printed. One of the best practices when you write Java code is to express it, right? So you can have a big variable name. You shouldn't be restricting on variable name, which makes it difficult for other programmers to understand. So it's good to have big variable name versus small one, which is not that expressive. So here I said dummy string value to be printed. I'm printing integer value, which is nothing but dummy integer value. And here I'm printing. So we have two methods with the same name, but it's taking different data types as argument, and we are just printing it out. So I define a main method here, and I define manager. So we have instance of manager, say senior manager grade 2 dot display. I pass integer to it. I pass 100 to it, and I pass. So I have two method invocations here. One is first one we are passing 100. The second one we are passing string to it, and it gets resolved. You could see that the first one would go to this display method which says printing integer value. The next one would go to this display method which prints string value. So you could see here, right? So first one is printing integer value, the second one is printing string value. So based on the type of the parameter that you pass through or pass to the method, particular method would be called. This is static polymorphism. Now what's runtime polymorphism? So since it is resolved during the compile time, it is static polymorphism. There are a few things that gets resolved during the runtime, or the compiler cannot judge it upfront what the instance would be, and that's when it does it during the runtime, and that is nothing but dynamic polymorphism or method overriding. So method overriding is mostly used in a either relationship. So in one of the methods, or we saw in vehicle and car example, we have a move method here, and here we overrode it. You can see a override annotation here for the move because we are overriding the behavior of vehicle in car class. So that's where it says that there's a easy relationship. Method overriding must be used in case of inheritance, that is easy relationship. Method must have the same name as in the parent class. We saw in the move, in the example move, we have the same name as in the superclass. So vehicle has a method move and car has a method move as well. Method must have the same parameters as in the parent class. As against method overloading, which has different parameters, method overriding, you have to be sure that it takes the same parameter. If I change this to integer, if I add an integer parameter to it, so it's not taking it as overriding. You could see it's not been taken as overriding because you have integer parameter to it. So basically it has to have same number of, or it has to have the same signature as your parent class. So that's about method overriding. Let's have a demo on this. So which we already saw, but I'll again reiterate on that. So basically in this example, you could see there's a man class which has got a pay method, which is adding behavior to the man method. And you could see it's a dummy print there. And you have a millionaire is a man, and you could see it overrides the pay behavior. When you run this program, one thing to note here is you can assign millionaire to man. You can assign, unlike all the examples that we saw, we are creating instance of the same class or assigning the instance of a class to the same class. But in this case, you could see the instance of millionaire is being assigned to reference of man. This is something that happens only in either relationship or inheritance. So what I'm trying to say here is I go to automobile management. I have car. I have a new car, which is Mercedes. I could assign this Mercedes to vehicle. Since Mercedes is a vehicle, it should be assigned. You should be able to assign it, right? This is something that you need to keep in mind. Your subclass object could be assigned to superclass. So here we have Mercedes being assigned to vehicle. But one thing to note here again is the tricky part is vehicle itself has its own move method, which prints move in vehicle class. And Mercedes, which is car, itself has its move method, which is move in car class. So the tricky part here is when you would do something like vehicle.move, just give a thought about it, which one should be called. So you have two variants of move method here. You have one in car and one in vehicle. So the one in vehicle is printing out move in vehicle class, and the one in car is the overridden version of vehicle which says move in car class. Now what we are doing here is we are creating an instance of a car class and we are assigning that instance to vehicle and we are calling the move method. So just give a thought whether the move method on the vehicle class would be called or a move method on the car class would be called. So this is where method overriding comes into picture. So method overriding is nothing but it's a runtime polymorphism which is done at the runtime. So during the runtime, JVM would see that Mercedes is nothing but the instance of car. Though it's assigned to vehicle, which is superclass, still an instance of class. So during compile time, JVM wouldn't have upfront knowledge that which move are you calling? Is it on vehicle class or is it on something else or some subclass of vehicle? So it doesn't decide it during the compile time. It delays it, or there's a lazy binding that happens, delays it till the time you run it. So when you run it, it understands that this vehicle is actually pointing to car, that's Mercedes. So when you run this, you could see that I'll comment out this piece of code. So this is how we comment out. That's a block comment. So when I move this, you could see that move class on car is being called and not vehicle. That is what is, if you get this concept, you're pretty good in terms of object oriented, by the way. This is an important concept in object oriented paradigm. So you could see here move in car class is being called. Similarly, vehicle could have, I call it as vehicle one, right? I define one more vehicle here, which is like new vehicle, and I invoke the method on vehicle two. So the second variant would call the move method in your vehicle class. The first one calls on the car class, the second one calls on the vehicle class, since it's an object of vehicle itself. So basically, you have to see on the right side which is the object that's been assigned. Since it's object of vehicle, it's vehicle. But since this one is object of car, that's the reason you have car class being called. So we had some discussion on this keyword yesterday. So super keyword is similar to that. Super keyword is just that it is called on super class. This is called on the same class. Super is called on the immediate subclass, immediate parent class. You could have multi levels, right? But this one is calling the immediate parent. Used to refer immediate parent class instance variable, used to invoke parent class method. And there's one more super keyword, one more form in which you could use is to have class constructor. So basically, whenever you create a class, whenever you call a class, whenever you call constructor of a class, by default, JVM by itself would give a call to the superclass constructor, which we would be looking at in the further slides. So here we have vehicle 11, which is a superclass which defines string wheels. Vehicle moves because of wheels. So that's a string, that's a property of a vehicle. You have a truck which extends vehicle, and then within truck you have your overriding the wheels property saying that truck has 4 wheels. This is kind of your overriding the property. It's not called overriding though when it comes to properties, but basically you're changing the values within your truck class. Print wheel is nothing but a method that's defined in a truck which would print the number of wheels in your truck class, and it has got super dot wheels which would print the number of wheels in your, or print the value of the wheels, not number of wheels, value of the wheels property within your vehicle class. So we will look at this one. So we have a vehicle class and we have a string wheels, which is a property within a vehicle class, which has some value put in, right? We have a truck class again, which has got wheels and it is overriding the value. It is just changing the value as truck has 4 wheels. Within truck class, you have print wheel method, which is printing the wheel or the value that this particular wheels property holds. It would print it. First one would be the value that this particular truck class would hold. And the other one that you see here, the second print statement, which is doing super dot wheels, is actually printing the value of wheels in vehicle class. So let me show you a quick demo on this thing. So we have a vehicle class, which wherein we are defining the default number of wheels as 4, say for example. And now we have a bike class, which is overriding vehicle class. And what we are going to do here is we are going to change the value of number of wheels. I have a method to print number of wheels, which would give, so suppose I change here number of wheels to say 2. So here we print number of wheels first, and I would have one more print statement which would be printing super dot number of wheels. Within a bike class, we have a print number of wheels method. First, we are changing the number of wheels to 2, and then we are printing the number of wheels for bike and number of wheels on the super class. All right, and by default, we have set the number of wheels in the vehicle class to be 4. So we have a bike class. Now I remove this too. So now I print the number of wheels. So I create the instance of bike and I invoke print number of wheels. Now you would see that first it would print 2, and on super dot, basically this is what it's going to call. So first it will print 2. So basically here we need to have one more integer number of wheels. When it comes to instance variables, it's not overridden as such. So I have like number of wheels defined here again, and here I change number of wheels to 2. So let me run it again. So when it comes to instance variable, when you define one more field here of the same name, it's not overriding it, it's rather creating a new instance variable. So now you could see that when you print number of wheels, it's printing out 2, which is nothing but the value here, value of this instance variable. Whereas when you do super dot number of wheels, you have a default value of 4 here, which is being printed out. So on super, it gives a call to super class. So here you're creating, it's at the constructor level, and we can see that. So it's more about, as I mentioned, within your constructor, the first thing that is called when you create a instance is the super constructor is called first, and then your subclass constructor. What I mean to say is when you create instance of car, so your first thing that would be called is the constructor of vehicle, and it would do all the initialization that's required in vehicle, and then it would call the car's constructor. So what I mean to say is, for example, I create a constructor here and I print saying that we are within constructor of vehicle of superclass vehicle. Now we have this car class, and say we have constructor for car class as well. Remember we said that there's a default constructor, implicit constructor that's already been put by JVM itself. You don't have to take care about it. So I don't do anything here. So basically you need not you did not write constructor. JVM by default writes constructor unless you want to write something or you want to initialize something. That's when you would write explicitly, you would write constructor. But in this case, since we are not initializing anything as such, I won't put a construct for car. What I'm trying to say is we are creating an instance of car here, and let's see, when we create the instance of car, there's a super constructor that's been called. That's what I wanted to show. So that's why we created a constructor here for vehicle. This is not a method, this is constructor, by the way, since it has got the same name as your class and it doesn't have any return value. So I've printed it out saying that we are in the constructor. When we call this now, when we create the instance of car, you could see that this constructor of superclass, that's vehicle, that's been called. So this is done implicitly by compiler. You don't have to care about it. So here you could see whenever you create the instance of car, you would see that we are in constructor of superclass vehicle. And the second print statement that you see is directly for the vehicle instantiation. So even for car, you could see, so this will get rid of confusion. So there's only one instance of car being created, and we can see that it is calling vehicle constructor. And it's implicitly put, we don't have to explicitly put it. JVM by itself operates that way. And how it calls is nothing but by super. Final keyword, we again touch based on this one earlier in the session number 1. Final keyword is non-access modifier applicable only to variable, method, or a class. When it's applied to a variable, we say that the variable content cannot be changed. Usually use final when you want to define a constant within your application. So that's final. A method could be defined as final. You define a method as final when you say that your subclass cannot override it. That's when you define it as final. You define a class as final when you say that there cannot be any subclass of that class. So you cannot subclass it. Like if you try to extend on a final class, you would get an error, compile time error, saying that you cannot extend it. So just to show you, maybe if I make this as final, your car would show an error saying that you cannot inherit from final class, that's com.edureka.vehicle. So that's about final class. And if you make this method final, you would again get an error in the class saying that you cannot override this. In the car class, you are trying to override the move method. Since it's final, it's showing you an error saying that move cannot override move in com.edureka.vehicle. Overridden method is final. Let's remove this final and you should see the error is gone. And also, if you want to see at the instance level, if you define this as 4, number of wheels as 4, now within this vehicle, if you're trying to modify this number of wheels to 2, it would throw you an error saying that cannot assign a value to final variable. All right, so that's what it is. It's not an access modifier, but it regulates it in a way that you can't change the value. In case of variables, you can't change the value. In terms of class, you can't subclass it, or you cannot create a child class of a final class. And in terms of methods, if you have final method, you cannot override that particular method in your subclass. So final modifier can be applied to class, method, instance variable, class variables, local variable, and method parameters. So final variable is used to create constant variables. When it comes to variable, as I said, usually you use final variable when you want to have constants, right? And it would be final static, by the way. If you have a constant, it's usually final and static final. Final methods is used to prevent method overriding. In terms of method, in the demo that I showed you previously, we saw that we cannot override it. In terms of class, when you have a final class, you won't be able to create subclass of it, which we saw, right? It gives you an error. Some examples of final class in string class. So system class in java.lang.package is final as well. String class that we have been using, string class that's been exposed by, or Java itself has, or Java by itself defines it, that class is final as well. If you try to extend string class, it would show you an error. It would give you an error. So system is kind of putting a contract, or Java by itself is putting a contract, or is saying that cannot extend the string class. You cannot extend its behavior. You can't change anything, any of the behavior within your string class by your own. That's why they have marked it as final. If a method is declared as final, then it cannot be overridden in your child class. If a variable is declared as final, then you cannot change the value of that particular class, or cannot change the reference of that particular class when it comes to objects. So we'll see that later. A constructor cannot be declared as final. So that's a rule. You cannot declare the constructor as final. And blank final variable should be initialized in constructor. So maybe in this case, if you wouldn't have any value here, you declared this as final. If you don't have any value here, it has to be assigned in constructor. Right now it's giving an error saying that it's not initialized. If you mark it as 4, it should be gone. So it's mandatory that if you put an instance variable as final in class, it's mandatory that you assign some value in the constructor. If you don't, then compiler would throw an error. So here you can't override it. So basically you have a final method void run, and you have a subclass of vehicle, and you're trying to override the run method. It shows you an error. So this is what we saw in case of move was final, and when we tried to override it in car, we got an error, and it's all compile time. If you declare any class as final, you cannot override that class, which we saw. It gives you a compile time error. So when you declared a vehicle as final, and when you try to create car class, which extends vehicle class, it gave you an error because vehicle class was declared as final. Again, this is a compile time. Now, what's dynamic binding, which is also known as runtime polymorphism, is nothing but during runtime, it decides which instance of a method should be called, or which method should be called. So this is in case of, again, inheritance, and when you override the method in your subclass. So we saw this earlier. Again, just to show you, we had this move method here, and in car you have this move method, and in automobile management we did this thing. We have a Mercedes that is assigned to class reference, rather, vehicle class reference named by vehicle 1. And in the second thing, we have vehicle itself. So first one is pointing to a object of car, which is Mercedes. and the second one is referring to object of vehicle itself. So this is what dynamic polymorphism is all about. The first one gives a call to the move method in car. The second one gives a call to the move method in vehicle. So yeah, you could see here. So move in car class, and then it calls a move in vehicle class. And it happens at runtime. That's why it's runtime polymorphism. So abstraction is a mechanism of hiding the implementation details from the user and only providing the functionality of a user. So basically you could have abstraction wherein on the first day we spoke about the shape class and the circle class and triangle and square and stuff like that, right? So basically shape is a class which is an abstract class which doesn't know all the functionality upfront, or it doesn't have all the behavior upfront. It doesn't know what would be the behavior of a circle class, or it doesn't know what is the behavior of a square class. When I say behavior, it's nothing but calculation of area. Calculation of area is nothing but it adds behavior to the class, and calculation of area in your square class would be different. Calculation of area in your circle class would be different. So shape by itself doesn't know what's the implementation of area method, I would say. So that is what is abstraction. There are two ways in which you could provide abstraction in Java. One is by abstraction class, which is not 100% abstract, which could have like abstract methods, like area in this case is abstract. But there could be some methods which is same throughout or common throughout all the subclasses of shape. Say for example, printing area. You just have to have a print statement which is printing area for a particular shape. From the implementation per se, it's same throughout all the classes. Area method would be something that is abstract, whereas display area could be something that is non-abstract method. So in such cases wherein you have blend of abstract as well as non-abstract methods, that's where you use abstract class. So it's not 100% abstract. Whereas in interface, interface is something which says that it has to be 100% abstract. So interface is altogether a new construct that we have in Java. When it comes to abstract class, abstract is just a modifier to a class. So you write class and you just prepend it by abstract, which makes that class an abstract class. Whereas interface is something that is a new construct that we are going to see in the coming slides. Abstract class and abstract methods. So abstract method is, as I said, area would be abstract method in this case, wherein you don't have a concrete implementation of area in your shape class. That's the scenario in such cases wherein you don't have a complete concrete implementation of a particular method, you would declare it as abstract method. And if you have an abstract method, if you have at least one abstract method in your class, you have to declare that class as abstract class, or else compiler would throw an error. So whenever you have a abstract class, it means that there is at least one method within that particular class which is declared as abstract. So when you subclass this abstract class, so shape for that matter, when you subclass shape, shape has got a area method which is abstract. Now when you subclass it, when you create circle, which is nothing but class circle, which extends shape, now you are creating subclass of it. In that case, you have to ensure that you implement area. If you don't implement area, it is still kept as abstract, and you will have to make circle class as abstract as well if you don't give the actual implementation. So an abstract method is a method that is declared without implementation. Any class that contains one or more abstract methods must be declared with abstract keyword. An abstract class is a class that is declared with abstract keyword. An abstract class may or may not have all abstract methods. So as I said, it's a mixture of abstract and non-abstract methods. An abstract class is mostly used for inheritance. So let me take the same example of shape and shapes. So we define a shape which would have abstract area. This is what I was saying. So when you have at least one abstract method, the compiler would throw an error. So in this case, it is saying that you have an abstract method, but your class is not abstract. So we have to make this one as abstract. And as I said, abstract class is nothing but a modifier. You just have a modifier that you need to prepend to the class. This is abstract method. And you say you have a method which is public void. It's not returning anything. We are just displaying area. Rather than defining it here, maybe I'll put something like So we have a shape method, and now I declare circle method. Now this circle method is extending shape. Now it's throwing an error and it says you have to implement the abstract methods. Shape has got abstract method. If you don't implement it, as I mentioned earlier, if you don't implement it, if you choose not to implement the area method, then you will have to make this abstract. If you make this abstract, the error would go off. But in this case, since we know the concrete implementation of area for circle, we'll have to implement it. When I say we'll have to implement it, we say area and we override it. So for simplicity reason, I'll just put some value here for now. Since we are talking about abstraction, I'll just keep it simple. So basically what we are trying to do here is we have implemented area, which would be nothing but your pi r square actually. So here we have a shape class and we are overriding the area method here, and this is how you abstract it. When you run it, so basically you could have something like, suppose I create a shape utility class. So this is pretty much like overriding methods. So you could have a shape class, shape circle is equal to new circle, and you could call circle dot area. So basically what you would get is nothing but a float value, which is your area of, let me put it this way, area of circle. When I want to print it, what I would do is circle dot display area, and I print area of circle. What we have seen here is there was an abstract method area which was implemented in your subclass, that circle, and when you give a call to it, and here you could see that again, similar to vehicles that we spoke about, instance of circle is being assigned to shape, and when you give a call to it, you could see that method on circle is being called and not on shape, because shape by itself doesn't have any implementation of area. So one thing to note here is when you have abstract class, so here you could see this value being printed out, right? Abstract class would have one or more abstract methods for sure, and when you subclass it, you have to ensure that you give implementation of your abstract methods. If you choose not to implement it, then you will have to make the subclass as abstract as well. So execution of abstract method, this is pretty much similar to normal execution that we have. So the main method, you have instance of mobile class created, this case. Then there's a default constructor of mobile class gets executed. So pretty much similar to normal execution. When you create instance of Nokia, which is subclass of mobile, as I said, the first statement that you have in the constructor of subclass is nothing but super, or it calls the super constructor. So here we can see that the default constructor for super is being called when you try to instantiate Nokia. As we are running run method, but in mobile class run is an abstract method. So run method from Nokia class gets executed. Similar to the example that we saw, so shape area class area method on circle got executed and not on shape. What is encapsulation? Encapsulation is a methodology of binding code and data together into a single unit. So basically everything, it's an encapsulation. It's put as one. So you could imagine class being put as one, right? Class has got this for that matter. You see everything being encapsulated as one, right? You group this together. You group this integer and long, which is a property of vehicle, and it has got some behavior as well, which is move. It's all encapsulated as one, or it's all put together as one entity. That is nothing but encapsulation. So basically, you could imagine a capsule, right, which has got multiple ingredients, which has multiple medicines or chemical components, which are put together into one capsule, and you think capsule as one medicine, but it's basically combination of chemical components within. Other thing is for encapsulation, there's access modifier comes into picture. You have this access modifiers of private, and you have public, you have protected, you have default. This access modifiers restrict, or it restricts the visibility of a particular component of a class, say method or variable or anything. So that's an encapsulation feature of object oriented programming. You can't see everything. It's not that everything is open for everyone. So you can have restriction. You have different levels of restriction when it comes to visibility of these components. That is a part of encapsulation as well. So to achieve encapsulation in Java, declare the variables as private. Usually the best practice is not to expose everything, because once you expose something as public, or once you expose it for the application to access, you have to ensure that you maintain it, right? Because anyone can access it. So your class is becoming much more fragile. I won't talk about these topics right now because fragility is something that is related to code quality or coupling, we say. So I don't want to touch on that, but basically the best practice is to have less visibility, restrict visibility or refrain visibility as much as possible. Try to make it as much less as possible. Make it private. Basically, if you could make all the variables as private, it would be a good thing. So basically, all non-private or public variables are liability for application. So it increases the maintenance of the application, and it's easy to break that way. If you make some changes to a class, it becomes very difficult in the future to maintain it. So usually the general practice is to keep the methods variables as private, not methods variables as private, and we have getters and setter method which are public methods or mutator methods which would expose this variable to the outside world through public. So usually we don't have setter methods, we restrict setter methods again. Usually you have a private instance variable and you have a getter method which is a public method which is nothing but returns the value of the instance variable to the outside world. So data hiding, the user will have no idea about the inner implementation of the class. What are the advantages of data hiding? User need not know the core implementation of the class. It increases flexibility. We can make variables and methods read only and write only as per the requirement. So imagine if you didn't have all these access modifiers, there's only one that is public, which is exposed to everyone. So it would create a havoc. So this is basically based on your requirements. You could have different patterns of this access modifiers used within your application. It makes testing easy. So basically, third point is reusability, easy to reuse and easy to change with the new requirement. So with reusability, even the maintainability of the particular application is improved when you have this encapsulation. And easy to reuse in the sense, if imagine the other way around, wherein you have only private methods. So a class could access only the instance variables within a class, nothing from outside world. It cannot be accessed from outside as well. Imagine such a scenario, right? In that case, you would have a lot of code redundancy, right? Everywhere you would write the same code. It might be the same thing you have already implemented in some other class, but you will have to re-implement it since it's not accessible outside the class. So that's how encapsulation increases the reusability of code, and it makes testing easier, of course. So here you could see that employee one. So this is the encapsulation mutator method that I was talking about. So basically you have employee one, which has got string name, which is private. You could see here it's defined as private. When I say private, this name property would be used only within this class. If you try to access it from outside class, you would get an error. But there might be scenarios in which you want to access this name from outside class. You want to understand what its value is. In that case, you would have something like this, right? You would have getter method, get name, which is nothing but its return type is string, which is the data type for name, and it's returning the name. Now, one thing to observe here is this is public. This one was private, name was private, but get name is public, which means it could be accessed from outside as well. Similarly, you could have setters, which is not a good practice, by the way. You shouldn't have setter methods. So again, setter is something like you pass the value that you want to set this particular name variable. So basically you are saying that whatever you send through this method is going to set to the name variable. So yeah, refer to this particular example in main. So you create an instance of employee one who have e dot set name. You are setting it to Alex, and when you access it, you do e dot get name. So basically what we are trying to say here is a demo encaps is a different class. It's not the same class. So you have employee one and you have demo encaps as a different class. Though it's a different class, still you are able to access your name, employee name from this class. This is again a private instance variable. You're able to do this just because you have these getters and setters. Let's understand interfaces. Interfaces are nothing but could imagine interface as a blueprint, or it is something that it's a specification rather, right? An interface could be thought of as a specification. This is how it should be. So basically it could be say a company manufacturing bottles or remote, right? It would say that this is how it should be. Basically there should be so and so buttons, there should be this button should be here, this button should be there, and something of that sort. So basically through interface, what we do is we specify the contract. We say that this is how it should be. Now, for example, you could have specification mentioned in a piece of paper. This is how a remote should be. And there could be different vendors for this remote who would be actually manufacturing remote and which would be aligned to this particular remote specifications. Then you could check that, okay, so and so specifications are met, which means that this particular thing could be used as a remote. So basically, these are nothing but these are specifications for the system. So through interface, you say that this is how it should be, and you would have different vendors or you would have different implementations that align to the specifications. And if they match up to the specification, it means that it's a correct one. So hence an interface contains all the specifications and can be used for creating a new remote. So all you see here, there's a joystick, there's AC remote, there's TV remote and everything. It has got different things, but there's something in common, and that's what you specify through interface. An interface contains variables and methods, but the methods declared inside interface are by default abstract methods. As we saw in the earlier slide, interface is 100% abstract. So all the methods that you have within interface is abstract. An interface is used to achieve abstraction. It is used to achieve loose coupling. When I say loose coupling, it's like you are not binding everything into a class. Basically, you say that if it's a remote, it has to have these features, right? So basically, you're kind of decoupling it, or you can say that all the implementations of remote will have so and so specifications, which has been introduced by interface. Also in Java, you cannot have multiple inheritance. You cannot have a class which extends multiple classes. You cannot have car which extends vehicle and which extends, say, for example, locomotive. Locomotive is one of the classes, say, for example. So you cannot have a class which extends two classes. That is multiple inheritance. Though you could have levels and you could have hierarchical inheritance, but you cannot have multiple inheritance. But through interfaces, you can have multiple inheritance. You could implement multiple interfaces, but not multiple classes. Again, since this is inheritance, interface is 100% abstract class, and basically you create subclasses from or you implement an interface. It's nothing but it follows either relationship. So what's the difference between interface and a class? An interface can never be instantiated. Just to give you an example, I'll show you what interface is. So instead of this class, I'll make this interface. So this is how we define an interface. We define interface, but as I said, an interface is 100% abstract. Everything has to be abstract. You cannot have methods, something of this sort. You cannot have a concrete implementation of method. Though you could have a default method, which we would be looking at in the slides to come. But at this point, let's imagine that you have a shape class and whatever methods you declare within your shape class has to be abstract. By default, it is abstract. You need not even mention it. By default, JVM puts it as abstract. Even if you mention it abstract, it's not a problem. It is abstract. So now, when I unlike extends that we do on class for interface, you implement it. So you implement shape class. So you'll have to make it public. By default, the access modifier for a method interface is public. So here you can see that we have implemented it. We could see that it's 100% abstract. So with this, you could see most of these differences being listed here. An interface should contain abstract methods, which we saw. Class can contain only concrete methods. We are talking about normal class here, not the abstract class. The members of the interface are always public, which we again saw. When I didn't implement this one as public circle, it gave me an error. So by default, it is public. The members of the class can be private, public, or protected. An interface can never have a constructor. Since we are not creating instance, the first point you can see that interfaces cannot be instantiated. Since we cannot instantiate interface, there's no need of constructor. A class can have constructor to initialize the variables, which we read yesterday. Implements keyword is used for inheritance, and whereas in terms of class, we have extends, which we saw now, right? For interfaces, we changed it to implements rather than extends. After extends keyword, any number of interfaces can be given. This is multiple inheritance that we spoke about. Whereas after extends, you can have only one and only one class. You cannot have multiple classes. Cannot contain instance fields. The only field that can appear in an interface must be declared both static and final. Can contain instance fields. So only the constants would be declared within your interfaces, whereas within class, you can have all levels of all the instance variables. Classes have implementation, whereas this is between class and abstract class. So classes have implementation, abstract classes have no implementation, or they can have implementation as well. So it's a mixture of abstract methods and non-abstract methods, as we saw. So abstract class is not 100% abstract, right? Unlike interfaces, you could have concrete implementation as well. Concrete classes are instantiated to create object. Abstract classes cannot be instantiated. Similar to interfaces, abstract classes cannot be instantiated. A concrete class can be final. An abstract class can never be final as it has no defined functions. For abstract class to be complete, it has to be extended. That's what the purpose is. Abstract class and interface is an abstract class can be extended to a class using keyword extends, and whereas interface can be implemented to a class using implements, which we saw. An abstract class can extend only one class at a time, and interface can extend number of interfaces at a time. So yeah, this is one thing wherein your interface can extend other interfaces, right? And you could have multiple interfaces extended. Abstract class can have private, default, protected, and public members. And interface members are by default public. In abstract class, keyword abstract is mandatory to declare a method as an abstract method, which we saw again. In interface, it's not mandatory because by JVM by default puts it. Abstract classes are to achieve 0 to 100% of abstraction, which means that you could have some concrete implementation as well, whereas interfaces are 100% abstract. You cannot have anything, you cannot have any implementation within. But you could have a default methods. Abstract class can have abstract and non-abstract methods. Again, yeah, abstract class can have constructors and interface cannot have constructors, which we saw earlier. Abstract class can have abstract and non-abstract methods since it's not 100% abstract, whereas interface can have only abstract methods. By the way, from Java 8, as I said, there's a default method being introduced, which is nothing but you could have a concrete implementation written within interface. Class interface relationship, you have class which extends other class, you have class which implements interface, you have interface which can extend other interface. If there's an interface already defined and you want to inherit some methods or you want to inherit the methods that you have within the other interface, you could do it using extends. A class extends another class while implements an interface, and interface extends another interface. Class cannot extend multiple classes but can implement multiple interfaces. So here you could see that there's one class which is extending the class on the top and there's one at the right side. It's trying to extend it. If you try to extend multiple classes, it would give you a compile time error. It won't allow you to inherit from multiple classes. Whereas in this case, you could see it's implementing multiple interfaces. On the top, you could see one interface being implemented by this class, and there's one more interface to the right which is being implemented by this class. Class cannot extend multiple classes, but it could implement multiple interfaces, which gives an opening for multiple inheritance. When any interface gets compiled, compiler automatically adds access modifier to the members. So this is done by default. It's an internal addition. So here you could see interface demo, which has got one variable that is int count is equal to 10, and it has got a method which is output. Now, when this demo.java, which is an interface which gets compiled, you could see that by default it has put it as public static final. So count 10 would be given access modifier public static final. So for variables, JVM by itself puts public static final. And for methods, it would put it as public abstract. So that's the reason when we had the area method, when we tried to override it, it gave an error saying that it has to be public. So John went to a bank. He wants to credit some money to his account. So let's see this one. So basically here you could see two implementation of it. You have money interface and you have operation as its method. So now you could see two implementations of it. One is debit and the other one is credit. Within debit, we are just saying that we are writing a dummy statement there saying that we are debiting money from this account. Whereas credit is nothing but, again, we are printing saying that we are crediting money to this account. So now when you create instance of money, or you create instance of credit and assign it to money and money dot operation, you would have operation method on credit being called. In this example, we can see that there's a shape interface which has abstract area, and there's a circle which returns this value, right? And say I declare one more class which is square, which implements shape, and it's again throwing me an error saying that you will have to declare it, you will have to implement the method. So I override this and say I return some dummy value like 100. You have a square, and inside circle, say I, so circle area, we are just hard coding it right now, we don't have to implement it. So it gives you 200, it's returning 200 as float, and this one is returning 100. So what we can do here is we have this shape utility. So here we have this thing called on circle. So I will just print it out here saying, and now I have one more, say for example, I create one more shape, which is square, nothing but new square. Now what we are doing is we are going to print out square dot area. So instead of assigning to a variable, you could do it this way as well. Area of a square. What we did is we have an interface shape and we have an area method which is abstract. We have two concrete implementations of it, circle and square, and we are instantiating circle and square here, and we are calling area method on it. By the way, you could see here that this is dynamic polymorphism. Circle and square has been assigned to the shape reference. It's not directly to the circle. You would see 100 and 200 being printed out. So circle was 200 and square was 100, and you could see 200 and 100. So it's basically dynamic polymorphisms followed in interface as well. You could extend an interface with another interface. So suppose you have one more interface, which is for now just to, so I create an interface, test interface, which has like test method. So you have a test interface which has void test, and you could have shape, which is extending test interface. Now your circle and your square would give an error because there's one more method that you need to implement. If you don't implement it, you will have to either make this abstract. If you make it abstract, it should go off. But in this case, suppose we want to implement it, then you will have to ensure that you implement test method as well. Once you implement it, the error should be gone. Similarly, in Square, you will have to implement it. So that's what is extending one interface with another, right? So basically here you could see there's walkable, there's runnable, and when you do it, when you implement runnable, you will have to ensure that you implement walk and run, both the methods. It's a class extending one class and implementing more than one interface. There's two interfaces, walk and run. So you could see animal, which implements walk and run. So then it will have to implement both the methods, walk and run. Whereas there's a human class which extends animal. So this is basically, there's a class which is implementing multiple interfaces and which has to ensure that it implements both the methods. So in this case, walk and run, it has to ensure that it implements walk and run. And there's one class which is extending from this particular class. And you could see here that you could assign human, which is extending, which is a subclass of animal. We could see that human could be assigned to walk and run as well, since it is implemented from there. So you could have h1.walk and h2.run, sort of. You're giving a call to these methods. So basically, this is again, if you understand the idea of runtime polymorphism or dynamic polymorphism, which is nothing but assigning the instance of subclass to superclass, you should get idea behind all this thing. We are pretty much talking the same thing. All this is talking about dynamic polymorphism. If you get that thing right, you are good enough. So we are talking about default method, right? Since Java 8, you could have default implementation within your interface. You could say that you cannot have a concrete method, but you could have, if you put a concrete method, something like this, it would give you an error. Okay, it gives you an error saying that it's not allowed. But you could have it as default. Once you define as default, it's good enough. So all these methods or all these classes, circle, square, and all these classes would inherit this. They can't override it, they can't do anything with it, but they would inherit this. They can give a call though, but they can't override it. So basically, I'll just show it here. So basically you have default method, which is say, and which is printing out hello, welcome to Edureka, right? And you can see here default class interface demo, which is implementing welcome. And you could see here hello being concrete implementation of hello, which is nothing but it's printing out the message that's passed to the hello method. So though default class interface demo doesn't declare say method, it inherits from welcome. When you do out.say, you could see the default method being invoked. Here we could see that, hello, welcome to Edureka has been printed out, which is nothing but the output of default method. So basically default methods are nothing but method which cannot be overridden, but is available for all the classes that implements a particular interface or implements that interface. So rules for using private methods in interfaces. Following are the rules for using private methods in interfaces. Private interface method cannot be abstract. Private method can be used only inside interface. Private static method can be called from other static and non-static interface methods. Private non-static methods cannot be called from private static methods. This might look confusing at this point, but you could think that first of all, private interface method cannot be abstract because we want it to be implemented in some other implementation, right? We cannot keep it private since interface by itself doesn't have the implementation of it. You want to implement that method in some other class, so it cannot be private. Private method can be used only inside interface. So if you define a private method within an interface, it can be used only within the interface. So basically you could have a default method which is private, right? So basically default method itself cannot be private, but within default method, so what I'm trying to say is, so here you could have private void, which is doing nothing, but here your default method could call this private method. So private method can only be used within the interface and it's usually used within default. A private static method can be called from other static. This is pretty much similar to other classes, normal classes. Private non-static methods cannot be called from private static methods. This is a common rule that we have. Private non-static methods cannot be called from private static method. So if you have a static method, within the static method, you cannot call non-static method. Remember we mentioned it earlier, unless we create the instance of it, we can't call it. But in this case, it cannot call it at all. So it's not on a class you're invoking it, basically within an interface. So private methods is specifically, you could call private methods from within your default method in interface. And since private methods are not accessible from outside, that's the only reason you could have private method in your interface. Static methods in an interface. So you could have something like this, wherein you have interface one and you have a static method display. As you remember, static methods are more of a class level method, right? You need not have to create instance of a class to invoke a static method. If an interface has a static method, you could call it directly by interface dot the name of the interface dot the name of the method. So we can have a static method like static. So this method could be called. So you could have something like this method and you could call it directly using the interface name. So we have this. So now within shape utility, you could directly call, like, as you could see here, you could call the static method directly by the name of the interface. You cannot have normal methods within it unless it's a default one. Interface features for different JDK versions. So interface has evolved throughout the versions of JDKs. So just to brief on that, we have JDK 1 to 1.7 having normal interfaces with constant static variables. As we said, the variables that you would have in interface are typically constants, which is public, static, final, and with abstract methods, of course. In Java 8, it evolved and we have a default method. As I said, there would be one default method which would be inherited by all the interfaces extending that interface. And you have static methods as well, which was not there earlier. In Java 9 and later versions, so in industry right now, it's mostly Java 8 that's been used across. Very few have gone to Java 9. All the big data frameworks and everything we have is supporting Java 8 at this point. So with the latest version, that's Java 9 and above, we have static constant static variables, abstract methods, default methods, static methods, and they have come up with these two methods which are nothing but private methods and private static methods, which was not there earlier. Now you could have these things as well. It makes very little sense to have all these scope variables, but maybe they might have thought something as a part of evolution. But at this point, I believe since these private methods cannot be called from outside, it's just that you have control over the default method. So basically, yeah, maybe if you have a big logic to be written within your default method, just to modularize it, just to break it into multiple methods, not to have one monolith big function or big method, you could have this private methods. That's what I can think. What is a package? We have been using package since day one. So package is nothing but it's a namespace. It's for avoiding collision. So basically I could write a name class with name shape, and maybe someone else within my team would write the same thing, right? So basically at the end, when we archive it together, like we have a jar file, which is Java archive. When we archive these files together, there's going to be name collision, right? You wouldn't know which shape class are you referring to. So basically namespace is nothing but it adds namespace to it and it avoids collision. Classes in the same package can access each other's members. So basically you can have within a package. So we'll talk about the import statements that will give you a clear understanding of what we are talking about. But basically within a package, as you could see here, we have not done anything to refer any of these classes. So it's within a package. We have com.edureka and we have all these classes within this package. So you could see that employee or maybe manager, which is a different class in the same package, we are accessing it directly. We are not doing anything different for it. But when you want to access it from a different package, you have to do something else, which is nothing but importing the package. The normal naming convention is usually domain name. Here you could see we mentioned com.edureka. So it's usually something of that sort. org.example.hyphenated name. It has to be in lowercase, usually written in lowercase. Companies use their reversed alternate domain name to begin their package names. So basically, if you have mypackage.example.com, you would have it in reverse order. This is typically one of the best practices or practices that's been followed across industry to define the package, but it doesn't have any constraints from the Java side as such. You could do anything. So for example, if I make it uppercase, so basically it's saying that it's not showing error because of it's in uppercase, but basically you don't have a directory starting with uppercase. As per Java or from the Java side, you don't have any constraints. For example, I could do something like, so basically it does convert it into lowercase even if you give uppercase. I don't know whether this is a feature in IntelliJ IDE, or it is, of course, it has to do something with the IDE because IDE is converting it into lowercase. As far as the Java naming convention is concerned, this is what we do, but it doesn't have constraint. Java predefined packages. So Java itself has many packages. So you could imagine the entire language being written in Java source code. So basically all this you would find in the source code. When we refer to the string, when we refer to string is a class which resides in java.lang. There's java.lang, which is nothing but java.language. So string is something that resides in java.lang. Object is a class which is a superclass for all the classes. So you know what superclasses are after we went through the inheritance thing. So you have superclass and you have subclasses. So the superclass for all the classes, no matter what class you use within Java, all the classes are inherited from a class called object. There's a class object in Java from which all the classes have inherited from, or all the class inherit from this particular class. Thread is used for multi-threading. Java.lang.thread is used for multi-threading. Multi-threading is nothing but two lightweight processes in order to leverage the potential of your processors. So if you have multi-core, then you could have multiple operations happening at the same instance of time. That's what thread is all for, to make it faster. You have exception class, you have system class, java.lang.system. This package is used to achieve the language functionality such as conversion of data from string to fundamental data, display the output on the console, and many more. The package is ported by default. So you don't have to specifically explicitly import this particular package. It is by default ported into your application. Java.util, this is like utility classes. You have collections and stuff like that into your java.util. This package is used for developing quality or reliable applications in Java or J2EE. This package contains various classes and interfaces which improves the performance of J2ME application. So basically, these are utility classes. It does something in terms of performance or does some conversions or something of that sort. Java.io is a package which contains something like file input stream, file output stream, and stuff like that, which is basically for interacting with your files, with your IO. So basically, if you want to load something into your memory, if you want to read something from your file or write something to a file in your local directory, you would use something like java.io package. If you want to do some kind of socket networking or some kind of network programming, you would use java.net, which has something like socket, datagram packet, datagram socket, etc. We have applet. Applet is nothing but an application that gets loaded into your browser. It's not used as of now. Earlier it used to be used, but now there are a lot of other technologies that have come up. But this is something like an applet is a Java program which runs in the context of WW or World Wide Web or browser. You have java.awt, which is like event driven. Like you could have UI applications. If you click on your checkbox or button, there would be an event triggered and you would have an event handler handling it. If you click on a mouse or something, you would have an event triggered. So basically all these classes are grouped into this package, which is java.awt. So you could see java.awt.event, which has like mouse listener. This is specific to event. So without these classes, it is impossible to handle events generated by GUI components. So as far as the front end is concerned, as far as all this AWT applet is concerned, it's not in use. Basically, Java is much more useful in terms of backend programming, which means you take data and do something with your data and stuff like that. But it's not well suited for UI applications, and it's not used to that extent in market or in industry. You have java.sql, which is nothing but all your database related stuff. So if you want to connect to your Postgre or if you want to connect to Oracle, you have all the stuff written in java.sql. So mostly in java.sql you have interfaces, and this interfaces, as I said, it's nothing but specifications, and these specifications are implemented by database vendors. So it's nothing but interface is just an abstract method. It would have like 4 or 5 abstract methods within. So all this concrete implementation, someone will have to implement to use these interfaces, or someone will have a class which will implement these interfaces, and we as developers can use those classes to interact with databases. So vendors like Oracle will have its own set of implementation to the specifications that are mentioned in java.sql. As I said, most of the thing in java.sql are interfaces. So about the access modifier, we have spoken earlier. We have public, we have protected, private, and default modifier. Public is nothing but it could be accessed from anywhere within your application. So you could have your methods as public, you could have your class as public, you could have your instance variables as public, which means that particular method could be accessed from anywhere within your application. You could have protected modifier. Protected modifier is nothing but your subclasses can access it and your current package. Whatever the package in which a particular method or particular class resides, in which you have protected method, you could access it from that class, or any class from that particular package access the protected methods defined within a class in that package. So I'll give you an example since we have spoken about inheritance now. So I'll give you a demo on protected. Private modifier is basically it's private, it's within a class. You cannot access it from outside. If you try to access it, you would get a compile time error saying that it's not visible. Default modifier is package, is public within package. So within package, any class can access it. So basically, it's like protected, right? Protected can be accessed within the package. Plus, it has like if your subclasses are outside the package, even those subclasses can access it. Whereas in default, it's just within the package. So protected has wider scope than default modifier. This is kind of public. So public has almost like everything. So widened scope. Then comes protected. Then comes default, and then comes private. So access modifiers, public. What are public? So when you have public access modifier within a class, in this case, you have two packages, edureka.pack1 and edureka.pack2, and you have some public members within your class 1 which we can see here that all these public members could be accessed by class 2, class 3, which is there in the same package as class 1, that is edureka.pack1. So now there are two classes in edureka.pack2. One is a class which doesn't have any relationship with class 1, but still it can access it, though it's there in a different package, but still it can access the public members of class 1. You can see class 4, which is a child of class 1, since it extends class 1, but it's there in a different package, but still it can access the public members of class 1. So protected is nothing but it could be accessed within the package in which the class is defined, and it could be accessed by members that are outside the package but child of that particular class. So in this case, we can see that there are few protected members in class 1 which could be accessed by class 2 and class 3, since they are in the same package as class 1. Class 3 and class 2 are defined in edureka.pack1. We have class 5, which is not related to class 1, which means it's not a subclass or it doesn't have any relationship with class 1. In that case, class 5 cannot access any protected members within class 1. So here we have class 4, which extends class 1, which is nothing but class 4 is a subclass of class 1, which is there in a different package, edureka.pack2, but it can access the protected members of class 1 since it is there in a different package. Private member is nothing but it can be accessed just within the class in which it is defined. So in this case, you could see that this is private members. So you have class 1, which has got private members, and you can see that class 2 can't access it, class 3 can't access it, neither class 4 or class 5. No one can access it. It's just that class 1 can access private members. So we have seen this in examples that we took in session 1. Default package. So default package is nothing but only within the package in which it is defined. So in this case, you have class 1, which has got default members with default scope. And you can see that class 2 and class 3 can access it, but not class 4 and class 5 since they are out of this package. Since class 2 and class 3 are defined in the same package as class 1, that is edureka.pack1, that's the reason you could access it from there. This is same for attribute or method. There's a table here which is summarizing whatever we discussed so far. You have modifier public. So yeah, it's within the class, yes. It's within the package, yes. If it's within the subclass, yes. And within the world, yes. So everywhere it could be accessed, right? That's why you have public. Protected is within the class, yes. Within package, yes. Within subclass, yes. But not within world. So it's just within package and subclass. But if you have different package, or if you have different package but it's not a subclass, then you can't access it. No modifier, which is a default scope within the class, yes. Within the package, yes. But we saw that it cannot be accessed within the subclass if the subclass is in a different package. When we say world is nothing but any package and they are not related. So in this case, the previous example that we saw, class 5 is something that could be thought of as class that are unrelated but reside in a different package. Private is just within the class. You can see that it's not with package. Within the package, it's not within the subclass, it's not within the world. So I think we have spoken about private, public, and default scope earlier. Let's start off with protected. So in the meanwhile, when it starts, let's talk about this. So here we can see package demo, which shows public. It has got a public method that is message. There are three ways to access the package from outside. So let me talk about how we actually code it. So there are three ways to access the package from outside the package. One is with import. In this case, like you had Edureka 1 and Edureka 2, right? The example that we saw earlier, edureka.pack1 and edureka.pack2. These are the two packages you have. If you want to access something, if you want to access class 3 from class 5, you would have to import edureka.pack1.class3 since it is outside the package of pack1. If it's within the package, so far the examples that we were taking was all within the same package. So we didn't have to import it. Now I'll just show you an example wherein you would